Hello everyone, and welcome to the course on Google Cloud Platform or GCP. So without wasting much time, we will move to the agenda of this course. There are 12 sections in this course, and each of the section will focus on some specific theme of GCP such as compute, storage, network, security, analytics, and so on. Every section will start with a learning objective that will help you understand what to expect from the section. I will also provide an overview of the services that are covered in that section, followed by a detailed discussion on each of the services. I will also make sure that there is a demo at the end of each section that will help you understand the concepts through the hands-on approach. Finally, we will summarize and wrap up the section with discussion on use case scenarios. I personally feel that this is the very unique approach where you take away when to use a service based on specific business scenarios. If you're going to take this course, I feel that you should know about your instructor. So my name is Vikash and I have a total of 9 years of experience working with different technologies like cloud, microservices, Spring Boot. Currently I work for IBM and I also have experience working with AI and machine learning. I have also worked on industrial IoT and MQTT. So for now, that's all about me, you should know. And let's move to the key takeaways from this course. Since this course is for absolute beginners, it is structured in such a way that you understand the most important concepts about Google Cloud Platform. So this course will help you understand the big picture of the Google Cloud Platform along with the essential building blocks of the GCP, such as compute, storage, network, identity management. We will also discuss about some of the additional services like databases, data and analytics, artificial intelligence and machine learning, DevOps, and some of the other services. So this course will help you get the big picture through the essential building blocks of GCP. Now let's move to the very first section of our course, that is overview of Google Cloud Platform. And this section includes the big picture of Google Cloud Platform, the key building blocks of the Google Cloud Platform, and some of the other services that are offered by this Google Cloud Platform. Let's look at the big picture of the Google Cloud Platform. So Google is one of the hyperscale infrastructure providers and its footprints are spread across the globe. You can see these dots here. These are basically the availability of Google Cloud Platform in these regions. It's America, Europe, Asia, and everywhere you can see it. To put things in perspective, let's look at some of the numbers that we have here. So Google currently has 20 regions, 61 zones, 134 cloud edge locations, and its customer is spread across more than 200 countries and territories. So what is the reason? A reason is nothing but the data centers. And each of the data centers is associated with zones. So typically when the Google will launch any region, it will be having at least two zones associated with that region, and that is for providing availability, reliability, and redundancy to the customers. When a customer will launch their application, they will launch it in more than one zones so that it is highly available to their customers. The network edge location are basically to serve the static content which will enhance the user experience, right? Along with that, Google is also planning to expand its services across South Korea, USA, and Indonesia. So this we discuss about its numbers. So these are the numbers that are currently available. Now let's look at some of the core building blocks of the Google Cloud Platform. And at the bottom of the stack, there is a compute service, which is the essential building block of any cloud service. And then we have the storage that provides durability and persistence to the application. And of course, we have the network that enables communication between multiple applications. So these are the basic services that a cloud provider should be having, right? So on top of that, there are databases, and the databases that are provided by Google can be both NoSQL databases as well as relational databases. Along with that, they also provide data and analytics tools that adds intelligence to the business application and data warehouse in the cloud. Google is also known for AI and machine learning, and there are few number of tools that are offered in this segment. On top of that, to serve different needs of the customers, Google also provides hybrid and multi-cloud infrastructure along with the API management and also migration facility for the customers who want to migrate from on-premise to cloud. And along with that, Google also provide security and DevOps tools to the applications, and these are spread across all the layers. And the most important thing that is offered by the Google is the management tool that is used for managing all its applications in a very smart way. Since GCP is an ever growing platform, we will not be able to learn all of the available services, but my objective is to ensure that you are equipped with the knowledge and the understanding of most of the critical building block services that are offered by Google, right? Now let's have a look at the key GCP services. And the first among them is a compute service. So as discussed earlier as well, compute is the foundational aspect of the GCP. And when it comes to the compute, there are lots of services that are offered by Google. There is infrastructure as a service that is provided by this compute engine. We also get the platform as a service or PaaS by this app engine. We get container as a service by this Kubernetes engine and function as a service by this cloud functions. We also have a cloud registry that manages Docker container images. We have a dedicated section where we will only discuss about these compute services. And the next key GCP service is the storage and database service. So the storage and databases provide persistence and durability to the applications. This includes services like block storage, object storage, and variety of databases including NoSQL, RDBMS, and in-memory databases. Like the compute service, we have a dedicated section for the storage and database where we will discuss about differences between the object storage and the block storage, and with a deep dive into the databases. We will also discuss about the differences between this Cloud Spanner, Cloud SQL, and so on. And the other key service in the list is network services. So what do you mean by networking? So networking, as you all know, it's used for connectivity. So how do it's used for connectivity? So in GCP, we can say that networking service will provide interconnectivity between our applications. How it does that? It has set of different applications in the cloud that will help doing the job. So for example, cloud virtual network that provides hybrid and isolated network capabilities within the cloud. Similarly, the cloud load balancing will distribute the traffic between different applications. And there are other applications as well like Cloud CDN, Cloud Interconnect, Cloud DNS that we will discuss in the separate lecture where we will discuss everything about the networking service. Now let's move to the next slide. So security is the most critical part of any application, and there are a set of services that enable customer to use the best practices for deploying secured application. There are services like Cloud IAM, Cloud Resource Manager, Cloud Security Scanner, Cloud Platform Security that deliver critical security to their customers. I have a dedicated section in which I will only discuss about the Cloud IAM, and I will explain you how to use least privilege security for protecting your resources from unauthorized access. The next in the list is AI and machine learning. So AI and machine learning provides some of the emerging set of tools and technologies to their customers to build an intelligent application. Now, what do you call an intelligent application? Whatever you type to your text, it will convert into a natural language. Whatever you speak, it will convert to the text. These are the services that use the artificial intelligence for making it possible. And Google Cloud Platform has a set of services from machine learning engine, which is used for a training platform in the cloud for the variety of APIs. We will discuss about it in more details in the dedicated section of this video series. So the next in the list is DevOps tools. So what is DevOps? DevOps means development and operations. Both combined together, it becomes DevOps. Now, why do we need DevOps in our applications? In the development and operations, there are a set of tasks that are repetitive in nature and require some manual effort. And DevOps tools provided by the Google Cloud Platform reduce this manual task and repetitive task by automating it. GCP provides some tools that can be integrated with the IDEs, and there are Google SDK deployment manager tools that can be used for making the manual work automated. Now, next in the section is management tools. Now, why do we need a management tool? In any cloud platform, if you don't have the management tools, you cannot manage and you cannot visualize what's happening in the backend. There are set of tools like stack driver for monitoring, there are tools for logging, there are tools for error reporting, the trace. So basically all these tools become very important when we are going to deploy our application on the cloud, and we have to manage and monitor that application constantly. So in the dedicated section we will cover some of the management tools that are very important in our day-to-day life. Now, apart from the services that we discussed earlier, there are some set of services that are provided by Google Cloud Platform which adds value to the GCP. And these services are API Analytics, IoT Core, VPN, AutoML, and there are so many services in the list that adds value to the Google Cloud Platform. Now, in this whole section, we have discussed so many services, and GCP offers more than hundreds of services. All of these services we will not be able to cover in this whole section. And the point is very clear that we want to focus on the building blocks of GCP, where you can understand the critical components of Google Cloud Platform, right? Now, let me go ahead and summarize what we have learned in this section. So, we have seen the Google Cloud Platform footprints, where and all it is spread, how many regions and zones are there. Then we discussed some of the core components of the GCP like compute, storage, network, and we also discussed that the platform has hundreds of services that are spanning over infrastructure, the platform, and the software as a service. We also discussed about the security tools, the DevOps tools, the management tools, and we just had a walkthrough of the services that we are going to discuss in this whole course. So that concludes the first session of this tutorial. I will see you in the next video, but don't forget to subscribe our channel because we provide everything for free. And if you have come this far, that means that you like the content and you will continue to watch the next session as well. So it's a request from you all to subscribe the channel and support us. This is the second session, and we will learn about how to getting started with Google Cloud Platform. So as a part of this video, we have total 4 learning objectives. The first one is we will look into how to sign up for Google Cloud Platform. And for that, you will require a credit card, and that's just for verification purpose. The next thing is we will learn about resource hierarchy, how the GCP manages the resources and their projects. We will have a look into that. The next thing we will look into is how do we interact with the Google Cloud Platform resources. And finally, we will have a demo on using Cloud Shell in Google Cloud Platform. So let's move to the first one, that is signing up for GCP. So for signing up for the Google Cloud Platform, you have to go to a website that is cloud.google.com/free. And in this screen, you can have a look at the services. So if you come down here, you will see that there are 20 plus free products that are offered by Google Cloud. And after that, they also provide you $300 of free credit for exploring and learning the Google Cloud Platform. After consuming this $300 of free credit limit, your services will stop. You won't be charged until you choose to upgrade. So for signing up, you have to click on this get started for free, and that will open up the sign up page. Here you have to select your account that you want to register, and I have a Google account that is already logged in, so that's why it is showing here. After that, you have to select your country and describe your organizational needs, for what reason you are creating this account. I'm just doing it for tutorial purpose, so I will just choose that the personal project, and then you have to select the terms and condition, continue. Next is your mobile number, you have to again continue, and then you will have to provide your payment details. So I will enter my card information here. And after entering all your details, you have to click on start my free trial. Then you have to enter your 3-digit CVV number here and then continue. Then you will get this screen where it will say that you will be, so your credit card will be charged and it will be refunded back again, and that's just for verification purpose. So click on continue and it will take you to the secured page where I have got to pay 2 rupees and I have to authenticate using a OTP that will come on my registered mobile number. Submit it. So it's a very easy process. It won't take even 2 minutes of your time and you will be getting started with Google Cloud Platform within minutes. And there are few mandatory questions that we have to just fill it here. You can select any whatever you want. Click on next, your interest, and what describes your role. I'm an developer and done. And you are ready to go with your free trial. So if you are able to get this welcome page, that means that you have successfully registered with Google Cloud Platform and you can explore all the services. Take some time and look at what all the things that are available here. And in this whole video, if we start any service, we will also go to close that service or delete that service after the end of this demo so that we don't go beyond our limit of $300 and get any bills at the end of the month. Although Google has mentioned that they will not charge, but we will not take chances. So now before going on to learn about Google Cloud Platform, we need to learn a few more things about GCP, and that is understanding the GCP resources. So in the Google Cloud Platform, anything that you launch becomes a resource. Maybe if it is a VM that you launch in the compute engine, or any apps that you launch in the app engine, or any topics that you create in the PubSub, or any kind of a storage that you create, that all becomes a resource, right? So everything that you create, you can say it as a resource, right? Now the next thing is these resources belongs to a project. That means that whatever the resource you create, that will belong to a project, right? You can say that this resource belong to this project and the other resource belong to other project, right? Now the project may be organized into folders. That means that folder will contain projects. There can be multiple folders, there can be single folders, and you can think of this folder as an environment. Maybe this is a dev environment and the prod environment. Inside that there will be projects and there will be resources inside that project, right? And the project here, this represents a billable unit. What does that mean? That means that this project you can associate with one credit card and the other project you can associate with other credit card, and based on the resources that you use, your both the credit cards will be charged, right? And these folders provides logical grouping to the projects, right? Basically it's for organizing everything and keeping everything very simple. As you progress with any of your projects, if you don't provide a logical grouping, your all the projects will be messed and it will be very confusing if your number of resources and projects increases. So the folder will basically provide the logical grouping to these projects. The next thing is these folders belong to organization and there will be only one organization where these folders will be represented. So you can say that a folder is the top level entity in the GCP hierarchy, right? So you can understand this with image that is represented here. You can see the resources that belongs to a project, right? And these projects are grouped into folders and there is a organization, right? But you can only visualize this if you have a G Suite account, or you can say professional account. Then you will be seeing this organization, the folder, and inside that you will be seeing the project. But if you have an account that is only for the private learning purpose, then you will be only able to see these projects, and inside that projects you will be able to see these resources. These will be only visible if you have the G Suite account, right? So we will have a closer look into this when we create any resource on GCP. The next thing is how do we interact with Google Cloud Platform? So there are four ways how we can interact with the GCP. The first one is the web console, where you will get the web console when you log in for the first time, and you can go to every resource and you can perform all the actions that you want to perform. And as a beginner, you should be more familiar with the web console, where you will get to learn how the Google Cloud is structured and how it works. And the next way of interaction is by using the Cloud Shell or by using the Cloud SDK. Basically, Cloud SDK is a CLI tool where you install it in your desktop and you start interacting with the Google Cloud resources. So this is basically used by the administrators or operations team to manage the resources on GCP. The Cloud Shell that is provided by GCP, that is like a CLI only, but only you don't have to install it in your local computer. You can use this web version of this Cloud Shell without installing that on your local computer. Google also provides mobile app that is available on Google Play Store for interacting with your resources. And if you want to access the resources programmatically, you can use this REST APIs that is very convenient and provided by Google. You can use any languages for interacting with it, like C Sharp, Python, Java, or any other language. Right now, let's have a closer look at this Cloud Shell. So this GCP shell is a very interactive shell environment that allows you to perform all the tasks that you can perform with the CLI, right? And it is accessible from any of the mainstream browsers like Firefox, Google Chrome, Internet Explorer, and basically all the browsers you can see. And it also comes with the preloaded IDE, that is this G-Cloud SDK. So you don't have to install any other IDE, and it is based on the GC VM. You can imagine that as whenever you launch a GCP shell, it will start a VM for you, and the size of that VM will be around 5 GB. That is a lots of space for performing this kind of task. Now you can also have an inbuilt preview of the functionality. That is, if you have any port configured in your service, you can directly access it from the browser with just a click of a button. Right now, let's have a demo on using the GCP shell. So for using the Cloud Shell, let's go to the browser. So this is our welcome page, and if you go here, you can see this activate Cloud Shell. Let's click on this, and when you are using this for the first time, you will see that Cloud Shell is free for all the users. That means that your $300 credit will not be used for using this service, right? Click on continue, and you can see that there is a Cloud Shell that is starting. Basically, it is starting up a virtual machine, and you can see that it is started. You can also launch that in a new window. So this is the console that we got, and you can perform any actions in here. Let me use the command gcloud compute region list, and it will ask you to provide your credential. So let me authorize it. When you use this for the first time, you have to set up your credential, and for getting the credentials you have to type here gcloud auth login, and it will give you a link. Just go to this link, and you can select the account linked with this cloud platform, and you have to click on allow, and you will get a code in here. So you have to copy this code and go to your Cloud Shell and enter your verification code. In that, you will just paste this code, click on enter. So you have successfully logged in with your account, right? Now let me give the command Google Cloud Compute Region List. So this will give you the list of regions along with the disk space and everything. Asia East 1, like that you will get the region names, right? So that's it for the demo. You can explore all the keywords that you can use with the Cloud Shell. Now let's finally have a look at the summary of session 2. So in this section, we learned that GCP offers $300 of credit in its free tier account. And we also saw that organization, folder, projects, resources are the part of GCP hierarchy. The next thing we learned was we can access the GCP through Web Console, Cloud Shell, mobile app, and REST APIs, right? And we also learned that Cloud Shell is a powerful tool that is available within browser. We don't have to install anything externally, right? So that concludes session 2. Hello everyone and welcome back once again. In this video, we are going to learn about GCP compute services. So let's look at the learning objectives. So we are going to discuss on the overview of GCP compute services, followed by a discussion around App Engine, the compute engine, Kubernetes engine, the cloud functions, and we will be having a demo on how to launch a VM in GCE, that is Google Compute Engine. And after that, we will be wrapping up the session with discussion around use cases of compute services. So let's get started. So now let's have a closer look into GCP compute services. Okay, so compute services are a critical component of any of the cloud platform. So why do we need a compute services? Basically, you write your code and you want to deploy your code somewhere, right? So these compute services basically are used for deploying your code onto any of the compute services. So when it comes to compute services, GCP offers a wide range of compute services where you can deploy your code. The first one is the app engine. That is basically platform as a service where you bring your piece of code and you just deploy it on App Engine and you will get a URL, and this URL you can use for executing your code on the App Engine, right? The next is the compute engine. So basically this compute engine provides you more control over your code. You bring in a piece of code and this compute engine it provides you a virtual machine, and this virtual machine you can install so many softwares and basically whatever you want you can deploy on that, and you can place your code in here and you will be able to run your code. So this is what the compute engine provides, a virtual machine which is more under your control. The next thing is the Kubernetes engine. So basically this is an orchestration platform and it uses containers. So you package your code in a container and bring it to Kubernetes engine. You deploy your code here, and this Kubernetes engine is responsible for maintaining your code. It will be taking up your code and it will be forming a container, and it will be responsible for managing the container, whether by scaling up, scaling down, number of pods that you want to create. All these things are managed by Kubernetes engine. Nowadays this Kubernetes engine is in demand right now, and the demand for the virtual machines are going down and the Kubernetes engine is taking over, right? And the next thing is the cloud functions. In here, the cloud function basically operates as a serverless. That means that you bring in your piece of code or write your code on these cloud functions, and after that you don't have to worry about anything. So we will look into more details in each of these going forward. Now let's have a more closer look on the app engine. So as discussed, app engine is one of the first compute services that was offered by Google, and it's a platform as a service, right? And you can say that app engine is a fully managed platform for deploying web apps to scale, right? So what does it mean by fully managed? That means that the developers don't have to worry about anything like provisioning, management, scaling, security. All these things are taken care by App Engine. The developers don't have to worry about anything. They just have to bring their code, and when the traffic comes in, the App Engine will be responsible for scaling up the containers for number of requests, and when the traffic is down it is responsible for scaling it down, right? So it's a fully managed platform and it supports multiple languages, maybe it is Java, Python or PHP or any other language. It is very well supported. You can write your code on any language and bring it to App Engine, and it will be responsible for running your code. So App Engine is available in two environments, and these are standard and flexible environment, right? So the standard environment basically When you deploy your code on the standard environment, it runs in the sandbox. When you deploy it in the standard environment, you don't have much control over your code. Whereas if you choose the flexible environment, you have more control over your code. You can manage, you can choose the dependencies that you want, and you can have more control over your code. Basically, this uses the Docker to deploy and scale the apps, right? Now let's have a more closer look into compute engine. So as I told earlier, compute engine provides you the option to create a virtual machine. So this virtual machine can be anything. You can install Linux, you can install Windows or any operating system of your choice on this compute engine. And it runs in the same manner as other of its own Google services like YouTube or other Google services, right? Now the VMs that you create are basically based on the machine types with the varied CPU and the RAM. If your requirement is to have more number of CPU cores, of course you can select that in the CPU configuration, and the RAM that is required for doing your job, that you can select it. Of course, these are virtual CPUs and RAMs, right? Persistence is available through standard and SSD disk. What does that mean? Typically, when you create a VM and you install softwares on it and you create anything, when you shut down that VM, all the things are lost, right? So that's a typical behavior of a virtual machine. So this persistence is basically available through standard or SSD. You can attach a SSD disk for allowing the persistence. Now the VMs are charged minimum of 1 minute and 1 second increment after that. That means that when you start up a VM, the minimum you will be charged for 1 minute, and even after 1 minute, if your VM is started, it will be charged on a 1 second increment basis, right? There is something called sustained used discount. That means that when you are running a VM for a significant portion of the billing month, that means that if you are running your VM for a month, so you will be eligible for sustained use discount. It means that you have to pay less for using it for 1 month. There is also something called commitment use discount. That means that if you purchase in such a way that you say Google that you are going to use it for 1 year or 3 year, you will be eligible for commitment use discount, and it will be much less than the sustained use discount. So this is the way that Google charges for compute engine. Now let's have a look at Google Kubernetes Engine. Google Kubernetes Engine is a managed engine for deploying containerized applications that are typically managed by Kubernetes. So, Kubernetes is the industry's most powerful and most popular container orchestration engine. It's an open source project that got originated at Google, but now it's a part of a larger organization called Cloud Native Computing Foundation, right? So Google, we can say that it's one of the original founders of Kubernetes and offers a very powerful dynamic container managed environment called Google Kubernetes Engine. You can bring your container images, package them as a Kubernetes artifact, deploy them, scale them through GKE, right? Now the Kubernetes has a control plane and a worker node or multiple worker nodes. It's a typical distributed computing environment where you have a control plane managing the worker node or the data plane that is running the multiple set of worker nodes. A GKE provisions worker node as GCE VMs. So when you launch a cluster in the Google Kubernetes engine, there are two elements. One is the control plane and the other is the data plane, which is typically delivered through a set of worker nodes. Now, the Google takes care of control plane and the master nodes that are responsible for managing the entire cluster. Okay, since Google controls the control plane or the master nodes, it is called as a managed environment. What is unique about the GKE is that the concept of node pool. So what is a node pool? So node pool is a collection of homogeneous VMs that delivers either high memory or high storage throughput or high CPU involvement. The service is tightly integrated with the GCP resources such as networking, storage, monitoring. For example, when you expose a service, in the GKE, it is going to be used in the load balancer. So of course, you can attach additional storage in the form of persistent disk to the nodes. GKE delivers auto scaling, auto upgrades, or auto node repair capabilities. And these are some of the unique capabilities of GKE. I know some of the terminologies we have used here may not be familiar to you, but that's not a cause of worry. We will have a detailed look in this in further videos. Okay, let's move to Google Cloud Functions. So, Google Cloud Function is something that was lately introduced by GCP. It's a serverless execution environment for building and connecting with the cloud services. Okay, so serverless, what does that mean? It does not mean that there are no servers attached. It only means that you don't have visualization of the server. It is internally managed by the cloud provider. Okay, so what happens that you write a piece of code, and that piece of code is a kind of a function, you can say, and this function is triggered based on an event. So you have written your 10 lines of code here, and what you do, you package this as a jar, and you go to the Google Cloud Platform and you open Cloud Functions, and there you upload your jar file. So when you upload your jar file, it only knows that you have uploaded the jar file and you have deployed it on Cloud Functions, but it is not running yet. When it will run, when any event will be triggered, that time only your code will run. Okay, so this Cloud Function supports languages like JavaScript, Python, Go. Okay, so GCP events fire a Cloud Function through a trigger. As I mentioned earlier, that you have deployed your code on the Cloud Functions, and it will only run the function when an event is generated. For example, an event includes adding an object to a storage bucket. So you have written one piece of code here, that what it does, it will take the image and it will convert the image to a thumbnail and it will store it to a storage bucket. When this event will be triggered? This event will be triggered when you will upload an image, and it will know that there is a trigger that you have generated. It will think it as a event and it will start running the code. After running the code, the output will be stored in the storage bucket, right? So trigger connects the event to the function. Okay, that's about Google Cloud Functions. So now let's get started with the demo. In this demo, we are going to launch a VM instance on our GCP platform. So for that, you have to select the project first of all, which project you want to create the VM. So I'm selecting this Techno tab. This is my channel name. So I've selected the project name. If you don't have any project listed here, you can just go ahead and create a new project from this window. I have selected the Techno tab, and after that I will go to Compute Engine, and here I will try to launch a VM instance. So you have to click on this create instance, and you have to select the configurations. I will leave the name as it is, and the region which is very near to me, that is Asia South 1, Mumbai, and the zone you can select any. I will keep it Asia South 1A, and after that you have to select the machine type. So I will keep it general purpose and the series as N1, the first generation, and after that I will select the F1 micro, that is well under my limits. It is showing estimated cost of $5 monthly. So I will keep it F1 micro, and that will be deducted from my credit that was given by Google. So next thing is we have to select the boot disk, and for that I will select Ubuntu standard persistent disk. I will leave the size as it is, and come down here where you see the firewall. You have to select HTTP traffics. This is important because we are going to launch a web server. Then you have to click on create. It will just take a few moments and it will create a virtual machine for you. Okay, so when you see this green tick, that means that your VM instance is created, and you will see the external IP, internal IP as well. So now let's go to our Cloud Shell, and you already know in the previous video we discussed how to go to Cloud Shell. So you have to click on this here, and it will open a Cloud Shell in the half of the screen, and you can also open that in a new window. I have opened it in a new window here, and I am going to type in some commands. So the first command that I will use is gcloud compute instance list, and this will give me this error saying that you haven't selected any project yet. So let me select the project. I also need to set the project ID. For the project ID, you have to go in here, and you have to select this project ID. Now you can use the same project ID here with this command. So my project is set now, and I'm in my project now. Now I have to check the list of instances that are already there here. So gcloud compute instance list, and I will get the list of instances that are there. Instance 1, ACS South 1, F1 Micro. So all these things are here. Now let me use one more command, and the command is gcloud compute SSH instance 1 and Jones ACS South 1A, that is the zone that I have hosted this instance 1. So this will install SSH on my instance 1. There is a spelling mistake. Gcloud. Do you want to continue? Yes. Enter a passphrase. I will keep it blank. Blank. Okay, so it has generated SSH on my instance 1. Let me run one more command here. Sudo apt-get update. This is updating my instance. So it is done now. And now we will go to install Apache 2 on this instance. So I will give this command sudo apt-get install y Apache 2. Enter it, and this will install Apache on your instance. So it has successfully installed, and now we will give one more command for starting up this instance. Sudo systemctl start Apache 2, and this has started. Now do one thing. Now let's go to our instance here and select the external IP, open in new windows, or copy it and open it in a new window. And you can see that Apache 2.12 default page. If you see this page, that means that your instance is successfully launched and Apache 2 is successfully installed on your instance, right? So this concludes the demo, and now I hope you might be aware how to launch a VM instance on GCP. And now let's have a detailed look at the use cases on how do you use the GCP compute services, right? Now let's have a look at use cases when you should choose a particular compute services. So on the leftmost side we have the GCE, that is compute engine, and the rightmost side we have the cloud functions, and the middle we have Kubernetes engine and the app engine. So the idea here is that when you move from left to right, you get highly customizable environment to a highly managed environment. That means that if you choose GCE, you will have the option of customizing your application to a very large extent compared to the cloud functions, right? So which compute services you should choose, that should depend upon your application, what kind of a customization you need for your application, right? If your requirement is to have a containerized environment, then you should go for GKE. If your application has a very simple requirement that event gets triggered and your application has to run on that event, at that time you should choose cloud functions, right? Now that's what I have tried to put it in the slide here. The Google Compute Engine is a infrastructure as a service, and its key feature is the virtual machine you will get, and it is very highly customized, right? And what kind of application you can deploy? You can deploy application which requires highly customization, your legacy applications, and all those kind of application can be accommodated by using the virtual machines. If your requirement is to use a containerized environment, then you should go for GKE, that is container as a service. Basically you can deploy your microservices and Java application jar files, right? And it's a containerized workload use case. The next is Google App Engine, and it's a platform as a service, and it's managed at the runtime. And what kind of application you can deploy? If you have a war file, a Java war file, you can deploy that on an App Engine. And the last is the cloud functions, that is functions as a service. And the key feature is the functions, and event-driven applications can be deployed on it. The code snippets that are triggered based on the event can be deployed on cloud functions, right? So this concludes the session 3, and if you have any kind of doubt, you can just go ahead and write it in the comment section. We will try to solve all your doubts. Welcome everyone once again. In the last video we had a discussion around compute services, and in this video we will completely focus on storage services of Google Cloud Platform. So let's quickly have a look at the learning objective of this video. So we are going to start with the overview of GCP Cloud Storage Services. After that, we will be having a look at cloud storage, which provides us the object storage capability. Then we will move to the persistent disk that provides us block storage capability. After that, we'll have a discussion around cloud file storage, which is cloud file as a service. And after that, we will have a demo on storing data in the cloud storage. And finally, we will close the session with a discussion around use case, when to use which storage service. All right, so let's move to the overview of GCP cloud storage. So the GCP storage services, what it has to offer for us. So storage services add persistence and durability to the application. So what does this mean? Persistence and durability. Let's go and understand these words in a more correct way. Let's suppose we have a mobile application, or we say that we have a mobile phone and there is a micro SD card that you insert in this mobile phone. So why do you add this micro SD card in your mobile phone? So this SD card you are inserting so that you can keep your videos and songs in this memory card for a longer amount of time. So persistence means to persist something into the memory card or the storage device. Then what's durability then? So durability means suppose after 1 year or 2 years, suppose your memory card gets corrupted, your all the data will be lost, right? So the durability means the ability to withstand or damage proof or saving it from the damage, right? So the storage device, what it does, it provides us persistence and durability to our application. Now, storage services are classified into three types. These are object storage, block storage, and file system storage. And GCP also offers you storage services that can store unstructured data and folders and files, right? So we will have a closer look into all of this going further. So now let's have a look at Google Cloud Storage. So this cloud storage provides us unified object storage for variety of applications. These applications can store and retrieve the objects through a single API. Okay, so that means you have a storage device, and you can write the data in this storage device by using this API. And also if you want to retrieve this data, you have to use the API, and this API is provided by Google Cloud Storage Service. So GCS can scale to exabytes of data, meaning it can store up 1 bits of data to infinite bytes of data. You don't have any restrictions on storing the data. The amount of data that you are storing, you have to pay according to that, and you don't have any limit on storing the data. And GCS is designed for 99.9999% of durability. That means that the chances of losing your data is approximately nil. You will not lose your data with the Google Cloud Storage. GCS can be used to store high frequency and low frequency access to data. So in a typical applications, you have data that you use it very frequently, and there are also some data that you don't use it very frequently. Let's say that there is a life insurance company and the users don't need the data every day. This data is accessed on demand. Maybe yearly once or twice you need this data. So GCS offers you to store the structured data and the unstructured data as well as high frequency data to a very low frequency data, which adds cost saving capability. Now the data can be stored within a single region, dual region, or multi-region. So you know that Google Cloud Platform is spread across many regions and zones, right? So if you want to store your data in a single region, you can very well go ahead and do that. If you want to store that in the dual region, or let's say in a same continent, then you can also do that depending on your security requirement and your local government regulatories. And you can also use to store your data in the multi regions. Now let's have a look at the storage classes and their types. The first in the list is high frequency access, and the class used for high frequency access is standard class. So high frequency access means the data that you want to use most frequently. The most common storage class that are used by developers and optimized for low latency or reduced latency means that the time taken for retrieving the data is very low, and this is very commonly used, easy to access. The second in the list is low frequency access, and the class is called nearline class, that is meant for data that is accessed less frequently. Typically for the data that is accessed less than a month, for those kind of data we use the nearline class. And the third in the list is lowest frequency access or cold line class. This is meant for data that is accessed very least frequently, and typically you can say that the data which is accessed once in a year, for those kind of data we can choose the cold line classes. Usually this cold line frequency is used for archival purpose or for the records that has to be kept for some minimum amount of time. For example, a transaction that you are doing today, maybe that has to be saved for 4 or 5 years. So in those kind of scenarios, we'll use the cold line classes, right? Now let's have a look at persistent disks. So as discussed earlier, the cloud storage service provides us the option of accessing the data through an API. And in the persistent disk, data is accessed using a block storage. Now the persistent disk provides reliable block storage for GCVMs. What does that mean? That means that persistent disk is used when you have a Google Compute Engine VM running and you want to attach a storage capability to this VM. In those kind of scenarios, you can go for persistent disk. So this is your VM and this is your persistent disk which adds storage capability to this VM. Okay. Now the disks are independent of compute engine VMs. What does that mean is that suppose you want to terminate this VM tomorrow, does that mean that your data, whatever there was there in the storage, will that also be terminated? The answer is no. That means that your VM can be terminated, but your persistent disk will be as it is separated from the VM. The next is each disk can be up to 64 TB in size, and that's a lots of space. 64 TB is a very huge size, and this is the size of one persistent disk that can be attached to a particular VM. You can attach as many as you want. Persistent disk can have one writer and multiple readers. That is one of the unique capability of persistent disks. It supports both SSD and HDD storage options. You can use the SSDs where your frequent operations is IO. That is, IO intensive applications can use SSDs. And finally, the PD is available in three storage types, that is, access-it, zone-wise, or regional, or local. So that's all about the persistent disk. Let's move to cloud file storage. So like the block storage and object storage, Google also provides us the file store system. Managed file storage service for the application, or you can say legacy application. It's a managed file storage system. Okay. So let's say that there is a legacy application which is an on-prem application, right? And it delivers NAS like file system interface and a shared file system. So this NAS like, what does that mean? Is network attached storage like. So in a legacy application, what happens, which is on-prem, it will be having a storage, or it will be accessing the data which is coming from different networks, right? So it's a network attached storage that can be replicated in the Google file storage. It's a centralized, highly available file system for GCE and GKE, that is Google Compute Engine and Google Kubernetes Engine. Mostly use this file store cloud storage. Now exposed as a NFS file share with a fixed export settings and default Unix permissions. So this capability makes your application feels like the application is running on the on-prem, but actually it is on the cloud. File store file shares are available as a mount point in GCVMs. So that makes it highly available. It feels similar to how your data is accessed when you are on-prem. On-prem applications using NAS-like advantage of the file store that we already explained. Now the file store has an inbuilt zonal storage redundancy for data availability. So like the other storage systems, it also has the zonal capability to reduce the redundancy for the data availability. Now the data is always encrypted while in transit. So whenever the data is in transit, it will be encrypted, and that adds the security, and that is one of the best feature of file store. So to summarize the file store, we can say that the on-prem applications which require a file storage type of system, when any application that has to be migrated to the cloud, these kind of settings will be required for moving the application from on-prem to cloud. And the Google Cloud File Store provides us with such kind of capability so that it is easier for migrating your application without any hassle. Okay, so now let's have a demo on Google Cloud Storage. And in this demo, we are going to create a bucket and store images in that particular bucket. So I am on my Google Cloud Console, and I have selected the project as TechnoTab that we created in our last video. If you don't have any project, you can just go ahead and create the project, but I will be selecting this TechnoTab only, and I'm going to create a storage. So in the search box, I will type storage, and I will select the cloud storage. There is no storage bucket available here, so we have to go ahead and create a storage bucket. So this storage bucket is nothing but your top level hierarchy in the Google Cloud Storage, and inside that you can have multiple folders, and inside that you can have data. So there are few steps that are involved in creating cloud storage, and we will walk it through. You have to pick up a name that is globally unique. That means that you don't have any pre-existing name available for this particular bucket. I will name it TechnoTab. That's my channel name, TechnoTab Storage. Okay, and continue. So the next thing that we will get is choosing the location type for this particular bucket. So there is a multi-region, highest availability across largest area. If you choose the multi-region, your availability for your bucket will increase, and it is up to 99.95% SLA. And if you choose a dual region, it will give you high availability as well as the low latency across two regions. And you can select any of these two regions. And there is a region that is also called as a local. That means that lowest latency within a single region. That means you will not be facing any kind of latency in the data. You will get the data very instantly, and that you have to select only one region for your purpose. Okay. So here you can select any depending on your choice. I will choose a region that is very local to me, and that is in Asia, Mumbai. Okay, let's continue. Now you have to choose the storage class that we discussed earlier. What kind of class you want? Standard, that is used by all the developers, where you have a frequent access of the data. If you want to access the data very frequently or you want to store the data very frequently, you have to select this standard. Or if you want monthly access, in a month you are using that data only once, in that case you can choose the nearline class. And there is a cold line class, which is the data which is accessed once in a year or quarter, or it's used for the disaster recovery. In that cases, you can choose the cold line. There is archive class that is used only for the purpose of long-term preservation of data. And if you see that the cost of choosing the classes will vary your cost of using the data. So for standard, it's free. For nearline, it's 0.01 GB per month. Cold line 0.20 and archive 0.50. It is the highest, right? So here I will choose the standard and continue. And the next step is to control access to the object. Enforce public access prevention on this bucket. You can select that. I will leave it default. So I will leave this uniform and I will click on continue. And after that you have to select the protection tool and you can select any retention policy. You can read and select whatever you want that is best suited for your type of data. For me, I will choose it none. After that I will click on create and it will just take some moment and my bucket will be created. So I am in my bucket and inside this bucket we have the Techno tab storage bucket, and inside that I will create a folder and I will say Techno tab images. Okay, and now I have this folder. I will go inside this folder and I will try to upload any file. So I will click on upload file. I will go to the picture that I want to store. I will store the logo, open, and you can see that the logo.png file is uploaded. And that concludes the demo. In this demo we saw that how we can create a bucket, what is the location, the storage class, the public access and the protection type that we choose for our bucket, and we also saw that how do we upload anything in this particular bucket. So that concludes the demo, and now let's move to the use cases so that we can understand where we can use which kind of the storage services. In this video, we have discussed three products of Google Cloud Storage, the persistent disk, and the cloud file store. Okay, so you need to figure out when to use which service, and that will depend upon your knowledge on how do you describe these three services. So the Google Cloud Storage is basically the object storage type, and it is scalable, durable, and a very long-term storage. It is centralized for frequently and infrequently accessed data. And we also saw that it can be accessed via using an API, right? And the persistent disk is a block storage system where you attach GCE and GKE VMs. It is used where there is a requirement of dedicated storage for a particular kind of VM and based on SDD and SSDs. And the file storage basically is a file system storage type wherever there is a requirement of NAS like shared file storage with standard Unix permissions. In those kind of scenarios where a legacy application has to be migrated to cloud, in those kind of scenarios your file storage will be very much helpful. In this section we are going to start with network services. So let's have a quick look at learning objective of this section. First of all, we will be starting with the overview of GCP network services, and after that we will move to network tiers. We'll see how many types of network tiers are there and what are their uses. Then we will move to cloud load balancing. After that we'll have a look at the VCP, that is virtual private cloud, and we'll also look at the hybrid connectivity. And after that we'll have a demo session on configuring the load balancers, and finally we'll move to the use case of network services. So let's get started with the overview of GCP network services. So the network services are one of the key building blocks of cloud. That can be any cloud, either Azure or AWS. It's the key building block of any of the cloud provider. Okay. So the GCP leverages the Google's global network for connectivity. What does that mean? So Google has a very expensive infrastructure, and on that infra, there are Google's own applications like Gmail, Google Search, or YouTube, and these are some of the best performing applications in the world. So the customers who are going for the GCP network services, they will be using the same network connectivity that Google services are using for their purpose. And that's one of the key advantages of using the GCP network services. Okay, now the customers can choose between standard and premium tiers. So when you are starting any network services, you have the option to choose between the standard and the premium tier. By default, if you don't choose any option, the premium tier will be selected and you have the option to change to a standard tier as well. Okay. Now the load balancers route the traffic evenly to multiple endpoints. So as the name suggests, load balancer that will be balancing the load, that is the amount of traffic that is coming. It will be distributing the traffic to different instances of the application. Okay. The next is the virtual private cloud VPC that offers private and hybrid networking. So in the public cloud, there will be some areas where you can launch your private instance, and that will be called virtual private cloud, that will be used for a security purpose and hybrid networking. Customers can extend their data center through hybrid connectivity. So further in this video, we will look at all these points in details. Okay. So now let's go one more step ahead and learn about the network service tiers. The network service tier provides a choice of traffic optimization. So what is traffic optimization? That means that you can customize the traffic based on the network services that you choose, right? What kind of performance you need from your network service, that you can choose by using this GCP network services. Okay. So there are two type of service tiers. One is the premium and other is the standard tier. Okay, so the standard tier will deliver traffic via Google's premium backbone. So this premium backbone, what does that mean? We discussed earlier, Google has a very expensive infrastructure where some of the Google own services like Google Search, Gmail, or YouTube are running. Okay, so when you select the premium tier, it means that you are going to use the same kind of network services that these premium applications of Google are using. Okay, and the standard tier uses regular connectivity based on ISP or Internet Service Provider networks or the third party networks. So the standard tier cannot match the performance that is delivered by the premium tier. So that's why this is a paid service, and when you choose the standard tier, it's a free. Okay. And GCP uses the premium tier as a default option that we discussed already. Whenever you launch a network service for your application, the premium tier will be selected as a default option, and you have the option to make it to standard tier. Based on the requirement that you have, you can optimize the traffic. Okay. Now let's try to understand the Google Cloud load balancing. So it is one of the most common services that are used by the developers and the DevOps team. Okay. So the load balancer distributes the traffic across multiple GC VMs in a single or multi-region. Means that when you launch a load balancer and attach it to your VM, it will balance the load in a single region or a local region. And if your application is hosted globally as well or in the multi-region, it can balance the load in multi-region as well. For example, if you launch up an application that has its instances in US and Europe, so when you attach a load balancer, it can route the traffic equally to US as well as Europe. Now there are two type of load balancers. One is the HTTPS load balancer and the other is network load balancer. HTTPS load balancer is a global load balancer. What does that mean? That when you have an application that is hosted in multiple regions or multiple zones, that time you can go for HTTPS load balancers. So you can say that it's used for balancing the load between multi-regions or multi-zones or global load balancing. And the other is the network load balancer that is used for regional TCP and UDP traffics. When you have your VM instances that are launched only in one region. Let's say you have in Asia Mumbai, that time you can use the network load balancer that will balance the load between different instances that you have launched in the Mumbai region, that is single region. Okay, now apart from being the global and the local, the load balancers can be internal or external as well. What does that mean? We'll see that by a architectural diagram. So in this diagram here, you see that there are mobile device or web applications and the users are coming from different regions. Okay, so it's US and Asia, right? So first of all, whenever any user will send the request, it will be intercepted by the external load balancer. Okay, so in this case, this is multi-region user. The user is from US, so the external load balancer will check the where the user is coming from, and in this case, the user is coming from the US, so it will route the traffic to the nearest region that is hosted. So in this case, you can see that we have US Central 1A, US Central 1B, and Asia East 1A. And the user from Singapore, that is Asia region, when it is intercepted by this external load balancer, the traffic will be routed to the Asia region. And in this case, it will be routed to the US Central region, right? So depending on the where the user is coming from, the external load balancers will distribute the load. Now, once the traffic is at the web tier, it has to talk to the database via some app servers, right? And these app servers are not one. There can be many app servers, right? So which server you want to hit, whether you want to go to this server, whether you want to go to this server. So there is a requirement of load balancing here as well. And that request coming from the web tier is intercepted at the internal load balancer level, and it balances the load equally to all these app servers in this region. Similarly, in the San Francisco region, it will be balancing the load all the app servers that are available in this Asia region, right? So you can use the combination of this internal and the external load balancing to achieve the scalability and better performance. And you can understand this from this diagram very well. All right. So now let's start with virtual private cloud or VPC. As you know that the applications deployed in the cloud demand high security and isolation, right? And that's where this virtual private cloud comes into picture. So as the name suggests, VPC is a software defined network providing private networking to VMs. So when you deploy an application, it's possible for us to create a private space within the public cloud and deploy the application within that area. And that area we basically refer it as virtual private cloud. VPC network is a global resource with regional subnets. So if you are familiar with the networking concept, you must know that it is possible to create multiple subnets as a part of VPC. So VPC is a global resource, which means you can create VPC that is visible from any of the region that you have in the GCP. And beyond that, you can create a subnet per region, which is going to be attached to same VPC. And that gives you a lots of flexibility, power, and ease of use. Each VPC is regionally isolated from each other. And this is one of the core requirement of virtual private cloud. This means that one VPC cannot see other resource deployed in other VPC because each VPC is running on its own isolated environment. Okay, so if you are creating multiple VPCs, you need to explicitly allow communication between these VPCs using the firewall rules. The firewall rules allow or restrict traffic within the subnets. So it is quite common for customers to create a public subnet and multiple private subnets and keep sensitive resources within the private subnets. And the private subnets are never exposed to the outside world. Resources within VPC communicate via IPv4 address, and there is a DNS service within VPC named resolution. VPC networks can be connected to other VPC networks through VPC peering. So if you are running multiple VPCs and want to share resources with other VPCs, then you need to create a VPC peer. A VPC network are essential building block for configuring the hybrid networks. And this is possible when you use the cloud VPN or the cloud interconnect. So VPC is the basic requirement for enabling hybrid cloud connectivity between your on-prem data center and GCP public cloud. So now let's understand what is this hybrid connectivity. So there are some legacy applications which are your on-prem applications, which are not on the cloud, which is on your local. And there are some applications which you are using to deploy it on the cloud. So hybrid connectivity means that your cloud applications, when it want to use the resources that are already there on the on-prem, that time you can use the hybrid connectivity services. So Google Cloud offers multiple mechanisms to extend your on-prem data center to public cloud. And that's what we call it as a hybrid connectivity, right? So hybrid connectivity extends local data center to GCP. So this is your local data center and you want to extend it to GCP. Okay, so you are moving these resources which are on-prem to the cloud environment. So how do you achieve the hybrid connectivity? So there are three GCP services that enable the hybrid connectivity, and these are Cloud Interconnect, Cloud VPN, and peering. So the Cloud Interconnect extends on-premise network to GCP via dedicated or partner interconnect. What does that mean? That when you are considering your local data center to move to the cloud, you can choose between the Google's own network that is spread across the globe, or you can go for one of the partner that Google designates for configuring the interconnectivity. All right. So if you don't want to spend a lot on the cloud interconnect and you want to achieve the secure connectivity, then you can go for Cloud VPN, which connects the on-premise environment to GCP securely over public internet. So it is very economical and very much affordable to extend your data center to cloud. Then there is a peering which gives you direct access to the Google Cloud resources with the reduced internet egress fee. And this egress fee is the bandwidth that you are charged for outbound connectivity. Alright, so you can choose any of these services depending on your requirement and budget. Now let's move to the demo part where we will be creating a load balancer and we will be routing the traffic to our web servers using that load balancer. So first of all, we need to create a web server on which we want to distribute the load, and then after that we will create the load balancer. For creating the web server, this time we will be using the instance template. Go to the search and type the instance template for compute engine, where we will be creating a template. Basically, this instance template will be having the blueprint of how our server will look like or how we are customizing the server, right? So let's go and create an instance template first. Okay, so I will name this instance template as web template. Okay, web template, and I will select the series as N1, that is first generation. You can see that the charges here will change according to whatever you select in your configuration. So I will be using the F1 micro. You can see the charge is reduced to $4.88, and I will leave the machine type or boot disk as devris. So default one I will keep it. I will not change anything in this one, and I will allow the default access, and I will also take this allow HTTP traffic. Okay, and in the management console we will be giving up a script here, and the script will be this one: git update install Apache 2. So this will basically install Apache 2 on our server, and we will create a file with the index HTML, and in that file we will be just displaying hello from hostname. So this host name will be variable here, and we will be using this script in this startup scripts. So whenever I am creating any instance using this template, it will run this script and it will install Apache 2 and default HTML page on that particular server, right? And then we will leave everything as it is and go and create. Now our web template is created, or the instance template is created, and now we will go and create the instance group. You can see here instance groups. So click on this instance group and create. This will basically launch up your instances. I will keep it stateless and I will name this instance group as web server. Okay, and I will use this instance template whatever we created just now. Now this is a single zone. I will keep it multiple zone, and I will use the nearest zone which is available to me. I will keep it Asia South 2, and the zones I will use all the three zones. Okay, now the minimum number of instances you can select here. Auto scaling if you want. I don't want auto scaling, so I will turn it off. And the minimum number of instances that I want for my web server is 2. So there will be 2 instances that will be launched. So I will keep the maximum number of instances as 2 because I don't want to create more instance. And after that, come down here. For auto healing, we will be creating a health check, and there is already a health check created here, webhc. Let me create a new one, create health check, and I will name it as HC web 2. Okay, protocol I will be keeping at HTTP, port is 80, and the path is root, and check interval, that is health check interval is 5, the timeout is 5, health check threshold is 2, and the unhealthy threshold is should be more than this healthy threshold. Let me keep it 5. Okay, so this health check basically what it does is that whenever you create an instance, every 5 seconds this health check will be checking out the instance if it is in healthy condition or not. So I will save it. So because the health check will replace unhealthy instance, you may want to increase the check interval to at least 10 seconds. We should not get this error. The health check interval as 10 seconds. Save. And the initial delay, so initial delay is basically for the first time when your instance is launched, how much delay you want for the first health check. 300 is a lot more time, so I will keep it 60 seconds, and that's it. I have to select this web template, and the number of instances I want to keep it as 2, right? So I am done with the configuration. Let me go and create. It might take around 2 to 3 minutes for creating the web server. Let me fast forward. So my web servers are created. If I go to the web server, I should see the 2 instances. Yeah, so there are 2 instances here. If you go to your VM instances, you should be able to see 2 instances with the web server name, and there is a unique name that is appended here with each of our web servers, right? Sorry, when we click on this external IP, it will open a web page, hello from web server. Okay, this is the HTML page that we configured, and the other one, you can see this. So both of them are having different host names, so that is visible here, right? Now we have created the instances. It's time for us to create the load balancer and check whether the load balancer is working or not. So we can go to the search and type load balancing. So network services is having this load balancing, right? And create load balancer. So we are going to use this HTTPS load balancing. We discussed the TCP load balancing and UDP load balancing, but we are going to use HTTPS load balancing because we have a multi-region instance selected, right? So start configuring, And here you will get the option only between my VMs or from internet to my VMs or serverless services. So we will be selecting this one because we are going to perform the load balancing over the internet, right? And it will be classic HTTPS load balancer. So continue, name this load balancer LB web. Okay, and these are the few configurations that we have to do. So the backend configuration, we will be creating one backend configuration. So in this one, we'll name it LB web backend, and the protocol should be HTTP, right? And the instance group we will be selecting here, that is our web server, and the port number is 80. And here you will have this option for selecting the rate and the utilization. So it's like how much CPU you want to use, and this is the rate, how much request you want to send per second. So we will be using this rate. Port number is 80, right? And we'll be using this rate, and the maximum rate is we'll be keeping it as 100 per second per instance. Okay, capacity is 100, leave it as it is. CDN, and the health check will be using is HC Web 2. We have not configured the security, so we'll leave it as it is. Click the done here, and then after that you can click here create for creating your backend configuration. So backend is configured. Now let's go to the host path roles, and we don't have to do anything in here. We will not make any change here. The front end configuration will go and create. So LB web front end, the HTTP protocol will be there, and the tier that you want to select is the premium tier, and it is over the public internet, and leave it as it is. Click on done, and then review and finalize. You can check everything is in place, and then click on create. So it will also take some 2 minutes for configuring the web load balancer. Let's wait for 2 minutes. So finally our load balancer is configured. Let me click on this LB web. So how do we test our instances and this load balancer if that is working correctly? So we have this HTTP protocol and this IP address here. I will copy this IP address, and I will, let me close this, and I will open a new tab and try with the web address that I just copied. It is saying not found. The URL was not found. Let me refresh it. So wait for some time, it will work. It is giving the server error. Please try again in 30 seconds. So let's wait for some time, because once you create the load balancer, it takes some time at least for this load balancer to reflect. So now you can see here, hello from web server S2B6, right? Let me refresh it again. You can see that this time the request goes to the other host. Now again click on refreshing. You can see that the host name will change. That means that our request is being sent to both of our servers, right? So this is the way you configure your load balancer. And in this demo we learned how to create the instance template, how to create the VM instances using the instance template, and how do we create the load balancing, how do we configure it, right? So that's it for this demo. Now let's move to the use cases of network services. So we discussed about this HTTP load balancing. It's a global load balancer for HTTP endpoints, and the use case will be CMS deployed in multi-region, right? TCP load balancing we discussed, and this is for regional load balancing of TCP and UDP endpoints. So typically this is used for gaming backend services. Then this VPC is the virtual private cloud that is used for private network within GCP. And the use case is to deploy GC VMs that are not exposed to public internet. And we also discussed about this cloud interconnect, where we have any on-prem application that needs to be kept on on-prem only, but it has to be used in combination with the cloud apps. So in that cases, we have to use this cloud interconnect. So dedicated network to extend local data centers, right? Access cloud resources from local application with a low latency. That's the use case. Then we also discussed about this cloud VPN, where if you want more cheaper options for extending your local data center, in that kind of scenarios, you can use this cloud VPN, and that is secure access to GCP resources through public internet. And we also discussed about this peering, wherein you can directly access the cloud resources with reduced egress fee. So this is the more cheaper option. Wherever you have a one-way communication, in that kind of scenarios, you can use this peering. All right. So these are the use cases, and that's it for this section here. If you have any doubts, you can directly write it in the comment section. In this section, we are going to start with one of the interesting topics of GCP, that is the identity and access management. We also call it as IAM. Now, let's quickly have a look at the learning objectives of this video. We'll start with the identity and access management overview, and then we will look at the key components of IAM. We'll also look at members, permissions, and roles. Then we will have a demo around exploring the members, roles, and permissions. And after that, we'll move to the service accounts, and we will also have a demo around these service accounts. Okay. And finally, how we wrap up the section with a discussion around use cases. We learned where do you use the IAM. Alright, now let's have a look at overview of Cloud IAM. So Cloud IAM is one of the most critical resource of GCP that controls the access by defining who has what access to which role. Okay, as simple as that. Who has what access to which role. Now here, who represents the members, then what represents the roles, and which represents the permissions. Okay, so IAM is all about connecting all the dots together, right? Now, Cloud IAM is based on the principle of least privilege. It means that whatever the resource you create in GCP, any members of the team will not be having access by default. Okay, and IAM policy binds identity to roles which contains permissions. What it means that when you create any resource on the GCP, let's say you have created one resource on the GCP, nobody is having any access to this resource. Okay, your members can not directly access this resource. Okay, these members has to go through the pipeline, and that is the members has to get the access to the rules, and these rules are nothing but a set of rules, you can say. Let's say that these resources are your VMs that are running on GCP, and it is having financial application. So you create a role of financial applications, and in this role you define what all the permission read, permission write permissions you want to give, or what all the permissions you want to give. You just mention it in this role, and you assign that role to the member. So the members cannot directly go to the resource, it has to go to roles to see what all the access they have to perform any action on this particular resource. All right. So the graphic in here will help you understand the concept in more better way. We have the roles and we have member identity. So member identity also called as principal, and the policy is the one that binds the member and the role together. So as you already know, roles are nothing but collection of permissions, and whenever any member want to get access to any resource, they have to be assigned to a role. So a storage admin or an instance admin role can be assigned to any of the users depending on their work area. All right, I will explain about all of this going forward. Now let's go one more step ahead and understand about this member identity or the users. So who can be the members? A Google account is one of the user. It will be having gmail.com extension with your username. That is a Google account user. Alright. There can be service account that can also be a user. More about this service account later. Then there can be a Google group. It can be a group of users that are having account in the Google. It can be G Suite domain, that is any organization having the G Suite domain. is also considered as the user can have many users in this, and when these users are requested access to a particular role, they will be given the access to this GC domain. Now, cloud identity domain. There are some users who create their domain on the cloud itself. They can also be considered as a user. The next is all authenticated users. It means that if you are using this alias on any particular resource, it means that all the users who are authenticated to sign in into that Google account will have the access to that particular resource. Okay, and there is all users. That means if anybody is having this alias access, it means that any anonymous person can access that particular resource. Okay, so there is a lots of flexibility that Google provides, which is some way or the other helpful for GCP users. Now let's understand about IAM permissions. So permissions determine the operations performed on a resource. Okay, what kind of operations you can perform on this resource, that is defined by the permissions, and this corresponds to 1:1 with the REST method on the GCP resource. It means that if there is a resource, there is a REST method that will be exposed by the resource to perform any kind of operation on this resource. So each GCP resource exposes a REST API to perform the operations. For example, let's say that you have a resource here and you want to publish something on this resource. So you must have this particular permission here that is exposed by this resource. That is, this resource has exposed a REST API and it will look something like this: pubsub.topic.publish. And if you want to publish something on this resource, you have to use this particular REST API method for publishing something on this particular resource. Now the permissions cannot be assigned directly to members. As we discussed earlier, that there are resources and there are roles and there are members, right? So if you want directly to perform any operation on the resource by the members directly, that is not possible. It has to go through the rules, okay? And this will determine whether this user can perform any operation on this resource. One or more permissions are assigned to IAM role. That is, there can be n number of roles here. Let's say that this is a IoT role and this is storage admin role. So this one particular user can have as many roles as possible depending on the project requirement to perform operations on different kind of resource based on their role in the project. All right, so this is all about permissions. Now let's move one more step ahead and try to understand about IAM rules. So first of all, what are rules? Rules are nothing but a set of permissions that are grouped together and assigned to the role. Okay, so there are primitive roles which has three type of access: the owner, the editor, and the viewer. So whenever you create any resource, the owner has all the access to perform any kind of operations on this resource. They can delete this resource, they can modify, or they can perform any kind of operations on this resource. Editor can basically perform some restricted actions. Maybe they can edit the resource or add permissions or make any changes as per allowed operations. Now the viewer, basically it refers to the read only access. So they can only do the read operations. They cannot modify this resource. Okay. So the second type of role, that is predefined roles. So the predefined rules, basically it can be a pub sub publisher or a compute admin or a storage object admin roles. Okay, so these are the set of rules that are already defined by GCP. You cannot modify these rules. For example, the member with the compute admin role can perform the operations like create the compute engine, destroy it, or manage throughout its life cycle. And these are the predefined rules. We cannot edit these rules as these are defined by GCP. And the third type of role is the custom roles. It means that you can have a combination of certain kind of roles. For example, you want to create a role and you want to have certain kind of actions to be performed in that role. If you want to have the compute admin and the storage object admin role in this particular role, you can very well go ahead and create this custom role and assign it to a particular user or member, so they can perform certain kind of operations related to compute as well as storage. Okay, so this kind of service is also available with the GCP. So you can get a fine-grained access to the resource, and it is very much useful when you have a very big team and you want to assign certain kind of role, certain kind of members. For example, the DevOps team may require certain kind of role to perform operations. The developers may require a different set of roles. So you can create a custom role and assign that role to that particular team. Alright, so now having understood so many different concepts of Cloud IAM, it's time for us to combine them all together and learn about the key elements of the Cloud IAM that will be helpful in moving for the demo. So we have learned that there are something called resource here, and the resource can be any GCP resources which represent a project, or it can be a cloud storage bucket, or it can be a compute engine. So all these things we learned that these are resources, okay? And to manage these resources we need set of permissions, and this permission is basically nothing but it determines the operations allowed on the resource. What kind of operations you can perform on these resources are determined by these permissions, and these permissions have a certain nomenclature, that is it will be defined in such a way that service dot resource dot the verb. For example, the compute.instance.insert permission determines that there is a permission to perform the insert operation, that is the user can create the compute engine. Similarly, the pubsub.subscription.consume, this kind of permission is used for performing any kind of publishing and subscribe task on a PubSub model. Now there are roles, that is nothing but collection of permissions, and the role are such that if you have the compute.instance.admin role defined for you, you can perform certain kind of actions on that particular resource. For example, you can start the VM, you can stop the VM, or you can delete the VM, and so on, right? And finally there is the user that represents an identity. These are the people or the members of the team or the DevOps team or the developer team that represent the identity. It can be in the form of a Google account or Google group or GC domain and so on. Okay, so it's very important for us to understand the difference between all these four key components, that is resource, permissions, roles and users. When we see it, we should be able to determine what is what. So you can spend some time in understanding all these key components. So now it's time to move to my favorite part, which is the demo part. So in this demo we will learn about roles and how do we create a role and how do we attach that role to a particular member, or in this case we call it as a principal. So I am on my Google Cloud Platform console, and I will go to the search and I will type IAM. I am an admin, and in here we are on to IAM console, and we can see the list of users that are already there here. So here you will see the principal. This is nothing but the name of the accounts, or maybe this is my personal account, this is a Google service account. So these all will be principals, and you can see the roles in here. What is the role of this particular principal? It's a editor. You can see the owner in front of my name. That means that I am the owner of this account and I can perform any actions on my account. Okay, so first of all, how do we create any role? So as we already discussed, the roles are basically the group of permissions that we assign to a particular person, right? Let's say that I want to create a role for my project that will only be assigned to the developers of my project. So I will go ahead and create a role and I will name that as a developer role, so that if a new developer comes to my project, I will just assign that role and he will get the access to all the resources that are required for him, right? So I will name it developer Java role. Description, you can add any. I will keep it as it is, and the role ID I will keep it as Java developer role 1, and launch state I will keep it as alpha. Now it's time for us to add the permissions. What all the permissions we want to assign to this particular Java developer. I will assign the role that are useful in creating the storage. So compute admin storage, this role I will be using, and I have filtered it based on the compute admin storage, and I will get the list of permissions that can be added to this particular role. There are 77 roles that can be performed. So what all action your user wants to perform, you can just check that I want to compute this create, then or we can provide a delete access and list. Let's say that these are particular permissions we are assigning to this storage admin. If we want, we can go ahead and add some more roles related to a compute engine as well, but this is just an example. You can go ahead and add as many roles as you want, create it, your new role is created, and you can see Java developer role. You can go and check the permissions, what role the permission this role has, and now you can go ahead and assign this role to any of the users you want, right? So let me go to the IAM console, and these are my users. If I want to add more users to the list, I can just go ahead and add the principal. So I can name anything. So this principal will be your user or the service account or the G Suite account, right? So let me give my other email address. That is okay. So this is my other email account. I have given it here, and I will select the role from this drop down. So I can filter out the role that I have just created. So custom role that I have created is Java developer role. I will assign this to this particular user, and I will save it. After saving it, you will see that this new user will come here, and you can see the role that is assigned to this user. So suppose tomorrow, if this user is leaving the organization, I just have to delete it. If this user is moving to some other project, I will have to assign some other role to this particular user, right? So it's designed in such a way that it's loosely coupled. It is not having any dependency, and it is very highly scalable. So that's one of the best use of IAM permissions. All right. Now that was a very comprehensive demo on IAM account. It's time for us to understand about service accounts. So what are service accounts? It's a special Google account that belongs to an application or VM. Means that it's a account that is associated with any VM. Let's say that you have a virtual machine here, and there are other applications deployed on the cloud, right? So these applications talk to each other internally. So how do these communicate with each other? It has to be linked to some account, and this is nothing but the service account, and this is used for communicating with other resources programmatically, right? So the service account is identified by a unique email address. So basically this email address will be very unique, and it might be automatically generated using your unique identifiers, maybe the project name or the project organization name. Combining all of this, it will form a unique email address for communication with each other. Okay. And service account are associated with key pair used for authentication. So it will be having a key pair that will be used for authentication programmatically for interacting with other resources. And there are two type of service accounts. One is the user managed, and other is the Google managed. So basically when you are creating any resource on the GCP, there will be a service account that will be created automatically by Google, and that will be called as the Google managed service account. As in the last demo I showed you, these two I did not generate. These are generated automatically by Google Cloud, and it is having the extension gserviceaccount.com, right? And it is having a unique identifier. So whenever you create a project, there will be some accounts that will be created, and it will be assigned some default role, in this case editor, that will be used for performing communication between different VMs or engines. Okay. And the another one is the managed user. So basically managed user is the one that we create and assign it some role so that it can be used as a service account for accessing the resources programmatically. All right. And the last is each service account is associated with one or more roles, right? It will be having at least one role, and you can go ahead and add more roles so that it can perform the task very easily. So I hope this will be very much clear what are service accounts. Now let's have a small demo where we will explore more about service accounts. Okay, as we discussed earlier, this is the service account that was created automatically. We have not created it. Okay, if you go here at the left side tab, you will see a section of service account, right? In the service account, you will be able to see all the accounts that are available. This was automatically created, and it shows the compute engine default service account, right? Now if you want to create your own personal service account that you want to attach it to any of the VMs and want to use this service account for communication with other resources on GCP, you can very well go ahead and create a service account, and you have to follow some steps for creating this service account. So the name of the service account, I want to perform some DV operations programmatically, so I will name it as DVS service. Okay, so this DVS service automatically took the account ID and it has extended that with the project name, that is here, and with iamserviceaccount.com, right? If you want, you can give description, then you have to create and continue. This is the first step. The second step will be to assign it some role, right? So a DBA service will be required to perform roles related to storage services, right? So I have to select a role for this service account. Role that I will select is the cloud storage admin role. Okay, so role is added. Now in the third step, grant user access to this service account. This is the optional field and we don't have to do anything here. It will internally have some certificate that will grant the access for communicating with other GCP resources. So when you click on done, your service account will be created. As you can see in the dashboard, this is the service account that we just created and its name is DVS service. So this service account is created successfully. When you go to the dashboard, you will be able to see that service account in here, and you can also see that a role storage admin is assigned to this particular service account. So I hope this will be clear how to use the service account. It's time for us to understand where to use the IAM services. So to share GCP resources with the fine-grained control, we use the IAM, right? To selectively allow or deny permission to an individual resource, we use IAM. And to define custom rules that are specific to a team or organization. This we can achieve by setting up custom rules, and along with that the Google provides some predefined rules that are the primitive rules and the custom rules that we define, and we can achieve a lot using these two rules. Enable authentication of application through service accounts that we just saw in the quick walkthrough, where we enable the authentication for communicating between the GCP resources using a service account. So this was the summary of what we have learned, and this completes the session on IAM. I hope you have learned a lot from this section. Hello and welcome back once again. In this section we are going to cover cloud database services. And the learning objective of this video, we are going to start with overview of GCP database services. After that we'll move to what is Cloud SQL, we'll learn about it. Then Cloud Big Table, the Cloud Spanner, Cloud Memory Store, and we will have a demo on provisioning MySQL database instance onto GCP. And finally we will move to the use case of database services. So without wasting much time, let's get started. So the overview of GCP database services. Like in the other sections, we talked about compute services, network services, identity and access management, right? And when we talk about GCP database services, it is also one of the critical component of any cloud provider, right? So what does GCP database services has to offer? We will look at here. So GCP offers you managed relational and NoSQL database services. All right. So the businesses which are traditional web or line of business that may use the RDBMS, that is relational database services, and it is provided by GCP database services. And as you know that the IT industry is adopting new changes, and one of them is they are switching to NoSQL databases. And this we call as a modern application that is very well supported by GCP database services. Web scale distributed applications need multi-region databases. This is required for the better availability and faster processing, right? This is also taken care by GCP database services. Okay, and finally there is a in-memory database is used for accelerating the performance of application. So this in-memory database comes into picture just for increasing the performance by using the cache mechanism and other mechanisms. You can very well accelerate the performance of your applications. All right. So now let's try to understand about Google Cloud SQL. So it's a fully managed RDBMS service that simplifies setup, maintain, manage and administer database instances. It means that you don't have to launch a virtual machine and you don't have to install any database physically into it. It is a managed service, which means that By click of a button, you will be able to launch a cluster of Cloud SQL and that will be fully functional. You don't have to designate dedicated database administrator. It is all taken care by Google. So the Cloud SQL supports three type of RDBMS, that is MySQL, PostgreSQL, and Microsoft SQL Server. All right. So it's a managed alternative to running RDBMS in VMs. In a typical application, what happens? You designate a VM, and in that VM you install a database server, and that is managed by some DB administrator, right? Cloud SQL delivers scalability, availability, security, and reliability of the database instance. So as discussed earlier, everything that is see here is fully managed by GCP. You don't have to worry about the scalability, availability, security, and reliability of the database instance. Okay. Now you can also launch up the SQL instance in a virtual private cloud for additional security. So if you don't want to expose your SQL to the front end facing applications, you can just launch up a VPC and you can launch up a Cloud SQL instance there and expose your all the backend applications to access the data from that Cloud SQL, and that will add some additional security to your applications, right? So that's all about Cloud SQL. Now after Cloud SQL, it's time for us to learn about Cloud Big Table. So it's a petabyte scale managed NoSQL database service. So what's petabyte? You can imagine 1 petabyte is equal to 1000 TB of data. That is way too much, right? So it is sparsely populated table that can scale up to billions of rows and thousands of columns. So you can imagine the size of the table. You cannot even think of a manual activity that you can do on that thousands of rows and columns, right? It's the big table that offers you table that can scale up to billions of rows and thousands of columns. So that's how the name comes big table. Now it also acts as a storage engine for large scale and low latency application. So large scale and low latency, that is one of the very common requirement nowadays for any enterprise application. Nobody wants lag in their application, so they are going for big table. Now it's ideal for throughput intensive data processing and analytics, right? Wherever there is a high read and write operations, in that cases this big table is very much useful. Now it's an alternative for running Apache HBase column oriented database in VMs. Apache HBase is one of the tables similarly to big table only, but it is launched up in a VM. It can also have very large number of rows and columns, right? So you can use this big table as the managed alternative to Apache HBase column oriented database. All right. Now it acts as an storage engine for map reduce operations, stream processing, and machine learning applications. So as you know, machine learning requires a very huge amount of data for the machine to analyze and learn from it, right? You can imagine this can only be achieved by using the big table. All right. So now it's time for us to learn about Cloud Spanner. And this is one of the GCP's very differentiating service from other cloud providers because it has lots to offer to its users. So it's a managed, scalable service for regional and global application data. Okay, it scales horizontally across rows, regions, and continents. All right, and it brings best of relational database and NoSQL database. So relational database here is known for its high scalability. Wherever you want to scale a relational database, you add more CPUs to it to get more better throughput, right? And the NoSQL database is based on nodes. If you want to scale up a NoSQL database, you add more nodes to the database. It's all NoSQL database is also known for better synchronization so that the data will be consistent across all its instances, right? So the Cloud Spanner brings best of relational and NoSQL databases. Okay. Now it also supports AC transactions and NC SQL queries. So in terms of microservices, nowadays ACID transaction is one of the requirement of every application. That is atomicity, consistency, isolation, and durability, right? So all these are supported by Cloud Spanner, and it also supports SQL queries. All right. So data is replicated synchronously with globally strong consistency. So you can launch up a different instance in different continents, maybe Asia, Europe, America, right? And data will be synchronized or replicated across all its instances in a very consistent way. Okay. And Cloud Spanner instance run in one of the three region types. Okay. So it's a read write or read only or witness. That means that there is a dedicated region that supports only read write operations, and there is a region that supports only read operations, and that will basically increase the throughput of the application because it is not having any write operation. So no, there is no any hold on the thread. That region is only dedicated for read only operations, right? And there is a witness. That means that across all these regions there will be one region that will be dedicated for synchronizing the data within all its instances. Okay, that means that it will maintain all the nodes of the application healthy and data will be synced in the real time. Okay, so that's all about the Cloud Spanner. So now let's have a look at Cloud Memory Store. It's a fully managed in-memory data store service that is based on a Redis. So what's a Redis? Redis is nothing but a kind of a database that acts as a in-memory in any application. Okay, so it's based on Redis. And you know what? When you have an application that is having very frequent call to the database, in that cases you can use this kind of memory store service where you don't have to hit the database again and again for getting the same data. It will be cached in the memory. Every time you go with the same query, the data set will be returned from the in memory, right? So ideal for application cache that provides sub millisecond data access. All right. Now cloud memory can support instances up to 300 GB and a network throughput of 12 Gbps. Okay. So if you see a typical application, it will be having a database and there will be front end of the application, right? So this is a DB and this is your front end application. And suppose if you want to query this DB frequently, you will every time go to hit this database. That will increase the cost of querying the database. Also, it will reduce the performance of your application, right? So Cloud Memory Store says that we offer you a 300 GB of cache. So what it does, the first time when you go to fetch the data from this DB, it will store the data in the cache and it will give the response to the front end. So for the next time, if you are querying with the same query, it will not go to the database, it will go to the cache and it will check if there is a result set that is already available in this cache and return it to the application. So you don't have to hit the database again and again. So the cache will act as a database for serving you the data, right? And it can store up to 300 GB, that is way too much of space, and 1200 Gbps of throughput. That means that it won't even take a milliseconds of time to get you with the data. Now it's a fully compatible with Redis protocol. It means that if you have an application that is already having a Redis in-memory cache installed, there will not be any code changes for integrating that application with the memory store. Okay. Now it promises 99.9% availability with automatic failover. Means that you don't have to worry about losing your data, and in case where this in-cache memory stops performing, you always have option to go to the DB and again get the data and store into cache. Alright. Now it's integrated with stack driver for monitoring. That means that you can, any error that is happening in the memory store, you can easily monitor and report that error or fix that error, right? So that's all about memory store. Now it's time for us to start with the demo. So in this demo, we are going to start with provisioning of a MySQL database on the GCP. So as usual, I'm on my GCP console and in the search bar, I will type SQL. I will get some results. In that I have to select this SQL and we will go to SQL dashboard. Now in here, if you don't have any instance created here, it will be blank. and you can go and create a new instance. So click on create instance and you will get the option to choose your database engine. So it offers MySQL, PostgreSQL and SQL servers, right? So we are going to start with MySQL, and we can now go ahead and start creating our instance. The instance ID, basically it is the instance name. Basically it is the name of the database that you want to give, and it should be a logical name that you cannot change it later. In this case I am giving it demo SQL1. It should be lowercase letter, number, hyphens, starts with a letter. Okay, and the next thing is the password. We can leave the password as blank, but it is a good idea to generate a password. So I will click on generate. This will generate a password for me. Let me visualize the password, and I will copy this password and keep it in a safe place. Alright, so our password is created. Now we have to select the version of the SQL that we want. I will go with 5.7. You can go with any of the latest version. I will go with 5.7. After that, choose regional and zonal availability. So for better performance, you can keep the data close to your service that need it. Okay, so region is permanent while zone can be changed anytime. So these all things you have to keep in mind. I want to keep it in a region which is nearer to me. Let me keep it Mumbai, Asia South 1, and you can select the zonal capability. So I want to keep it multiple zone, and you can select a primary zone and the secondary zone. So I will keep it any for now so that it can automatically select the best zone which is available to me. After that, you can customize your instance. So let's go through the customization once. As we were getting the option of choosing the machine type in compute engine, we get the option to choose the machine type here as well. It depends on your requirement what kind of machine you want. You can keep it lightweight, standard, high memory. Let me keep it high memory, and 4 CPUs and 26 GB of space I have selected. You can select as per your requirement. Now the storage is SSD that is recommended. I am not changing any settings in here. I'm just going to select this 10 GB because I'm just using it for demo purpose. So I'll keep it 10 GB. Now the connection, you can select the public IP and the private IP depending on the requirement. If we are selecting the public IP, that means our IP is open to the internet and anybody having the credentials can access the DV. You can select the private as well, but I will keep it public. Now the backups you can select to be automatic. It's always a good idea to select the backups. When do you want to backup your data, every weekly or what is the time, so that you don't lose your valuable data. It's always a good idea. Next is the maintenance. So maintenance activity is one of the important activity that takes place every few months, and you should always choose a maintenance window when you predict your traffic is very low. And you can also set the flag in here. I will keep it to default. Labels, basically you can add some more metadata in the labels. And that's about all the customization. And after that I have to click on this create instance, and it will start creating the instance. It takes around 7 to 8 minutes for creating one database instance. I have already created it. I will not create it again. So let's go and see my database instance. So the one I showed in the beginning, this demo SQL, this is the instance that I have created, and it is hosted in Asia South 1. All the configurations that we did, it's same configuration we have launched. We were able to successfully launch up this database instance. Okay, now let's start up this instance in our command line. So let me use the Cloud Shell, and the Cloud Shell is being launched. Okay, so the Cloud Shell is launched. Now I will just type gcloud SQL connect the database name, the demo SQL. Basically this will whitelist your IP for incoming connection just for 5 minutes. Generally we don't use the Cloud Shell for interacting with this database. This Cloud Shell can be used for the maintenance activities. So it is just activating it for 5 minutes. Okay. So after whitelisting your IP, it will ask you for the password. So in the beginning, I mentioned to copy the password. It's time to paste your password in here. So I have entered the password, and now we are into our MySQL database. You can perform any kind of queries now, like create database tables, or all those queries that you want to perform, you can perform from here. So that was a very comprehensive demo on creating a MySQL DB instance, right? So that's it for the demo. Let's move to our other section, that is the use case of database services. So the Cloud SQL is basically a relational database type, and it supports MySQL, PostgreSQL, and Microsoft SQL Server. Who can use this Cloud SQL? The traditional web applications and the business applications or the legacy applications can go and use the Cloud SQL. Okay, the Google Cloud Big Table, that is basically NoSQL database type, and it's a column oriented, right? So it can scale up to thousands of columns, and the big data and machine learning workloads we can perform using this big table. Then there is a cloud spanner, which is basically IDBMS plus NoSQL, because it can be launched many different geographical regions and it can be easily scaled. So you can use it for the application which is distributed globally. Then there is a cloud memory store, that is basically in memory DB type, and it has low latency Redis cache. Right? You can use this application wherever there is a frequent retrieval of data. In that cases, you can go and use cloud memory store. Okay. In the last section, we discussed about database services. And in this one, we are going to talk about data analytics services. So let's look at the learning objective of this video. We are going to start with the overview of GCP data analytics services. Then we'll have a discussion around Cloud PubSub, Cloud Data Flow, Cloud Data Proc, Cloud Data Lab. We'll also look at BigQuery. Then we'll have a demo on analyzing the data with BigQuery. And finally, we'll wrap up the section with discussion around use case of data analytics services. So let me set up the tone for this lecture by starting with data analytics services. So what does analytics mean? It's like analyzing or having a research on something, right? So we can say that data analytics include ingestion, collection, processing, analyzing, and visualizing the data, right? So you can say that it's a pipeline where you perform all this action on the data, right? And GCP has a comprehensive set of analytics services. So for performing all the actions on the data, you have maybe for ingestion, collection, processing. For every stage in the pipeline, the GCP has to offer some kind of a tool for analyzing and performing the task, right? So one of the tool is GCP PubSub, which is used for ingesting the data at a scale. So the PubSub model basically collects the data from some kind of sensors or from the logs, and it's based on the PubSub model, publish and subscribe. That means if there is any sensor that wants to publish the data, it will be publishing to a topic, and there will be an end user that will be subscribed to this topic. So whenever publisher or the sensor data changes, it will be published to a particular topic, and the end user who has subscribed to this topic will be able to receive the data on the real time. Now this can also be used for sending the logs to a particular topic. Okay, so the PubSub model is used for ingesting the data at scale, right? The next is cloud data flow, that can be used for processing the data in the real time or batch mode. So sometimes you have a requirement for processing the data in the real time. For example, there is a Netflix which perform analytics in the real time what you are watching, and based on what you are watching, it gives you a recommendation for the next show that you can watch, right? So for those cases, you can use the data flow. The next is Cloud Data Pro. That is a big data service for running Hadoop and Spark jobs. So there will be some data which that will be very huge in number, or you can say historical data or legacy data. You can use the data proc for analyzing it by running Hadoop and Spark jobs, right? Next is the BigQuery, that is a data warehouse in the cloud, and it is used by most of the organization nowadays. So the BigQuery works on a very huge amount of data. Maybe it can be terabytes or gigabytes of data, and you can perform any kind of queries on that data within seconds that cannot be offered by any databases, right? So BigQuery gives you the advantage of running your query in very short amount of time on a big data set. And finally, there is a cloud data lab that is used for analyzing and visualizing the data. It means everything will be represented in the form of a graphs, and you can visualize the data what's happening in the background by looking at the graphs. So the cloud data lab is used for that purpose. All right. Now let's have a look at the cloud pub/sub or publisher or subscriber. So it's a managed service to ingest data at scale. So as discussed earlier, any telemetry service will be publishing the data to a particular topic, and there will be receiver to this topic, right? And it's a managed service. So it's based on publishing and subscribing pattern. So somebody has to publish the data and somebody has to subscribe that topic for receiving the data. You can say that as a global entry point to GCP based analytics services. So all the data that are coming to the cloud is first intercepted with this pub/sub model, whether you have a telemetry unit or whether you have any logs or any kind of data that you want to send to the cloud will be sent via this pub/sub model, right? Now it acts as a simple and reliable staging location for the data. So you cannot think of it as a durable data store. Okay, you can think of it as a staging location where you get your data that is ready to be processed by some other tools of GCP like Cloud Data Store or Dataproc, right? Now it's tightly integrated with services such as Cloud Store, Cloud Data Flow. So once you have the data in the staging location, there are receivers to this topic. This data can be received from Cloud Data Store, right? So Cloud Data Store will be subscribed to this topic, and Cloud Data Flow will also be subscribed to this topic, or any other application that has to process the data will be subscribed to this topic. And that's what it says, like it is tightly integrated with all these services so that it can receive the data from this staging area and use this for further processing. All right. Now it supports at least once delivery with synchronous and cross-zone message replication. What this means is you get a highly reliable deliver mechanism, and it also adds redundancy because of this cross-zone message replication. All right. It comes with the end-to-end encryption, IAM, and audit logging. So all this mechanism gives you to secure your data and also monitor the inbound data coming from the pub/sub. All right. So that's all about pub/sub model. Let's move to the next topic, that is cloud data flow. So Google Cloud Data Flow is meant for transferring and enhancing data either coming via real-time streams or data stored in cloud storage which is processed in batch mode. And cloud data source is based on the open source project that is called Apache Beam, and it's serverless approach which automates provisioning management with serverless infrastructure and serverless computing. All right, you don't need to provision resources and scale them manually. Instead, you start streaming the data and connecting to data flow via pub/sub, and it can automatically start processing the data and scale the infrastructure based on inbound streams. Okay, and the inbound data can be queried, processed, and extracted for the target environment. So data flow is typically used for manipulating data or pre-processing the data as it comes into the cloud. So the cloud data flow is typically used for manipulating the data or pre-processing the data as it comes into the cloud. The input for the data flow could be Google Cloud PubSub, while the output of the data flow could be written directly to BigQuery or Google Cloud Storage or to one of the manager database services like Cloud SQL. So the cloud data flow is tightly integrated with some of the other data analytics services like Cloud PubSub, BigQuery, and even machine learning. Okay. And there is a cloud data flow connector for Kafka, which makes it very easy to integrate Apache Kafka. Okay, so if you already have a Kafka infrastructure with the connector, it is possible for you to breeze Kafka with the cloud data flow and get the best of both the worlds, which is Kafka streams and cloud data flow, which is based on again Apache Beam. So this cloud data flow forms a critical component of data analytics services of GCP because the data that is coming via PubSub or Google Cloud Storage is being processed, manipulated, and transformed with the cloud data flow. So that's all about cloud data flow. Now let's move to cloud data proc. So it's a managed Apache Hadoop and Apache Spark cluster environment. So if you have application where you want to launch up Apache Hadoop or Apache Spark, you should go with the Google Cloud Data Pro. So it's a automated cluster management. That means you don't have to do anything manually. You decide you want to launch up Apache Hadoop cluster. You just go to GCP and just by a click of a button, you can launch up a cluster which will be automatically managed. Now the cluster can be quickly created and resized from 3 to hundreds of nodes. So you don't have to worry about the scaling up and scaling down. It can be resized from 3 to hundreds of nodes within a very quick span of time. Now you can move the existing big data projects to GCP without redevelopment. So if you have a legacy project which is using the big data or any on-premise big data projects that you are running, you can easily move that to the Google Cloud Data Proc without making any code changes. Now it frequently updates the Spark, Hadoop, Pig, Hive, and other components of Dataproc, where you don't have to worry about the compatibility of the versions. It gets frequently updated. Now it also integrates with the other GCP services, Google Cloud Data Flow and BigQuery. So the data that is coming to the cloud that is intercepted by PubSub and output of the PubSub is input to the data flow where the data is getting transformed, and the output of the data flow can be input to the data proc where the data will be processed, and the processed data can be stored anywhere in the BigQuery or in any of the cloud database services, maybe like Cloud SQL. All right. So that's all about Cloud Data Proc. Let's move to the next one, that is Cloud Data Lab. Now the Cloud Data Lab is an interactive tool for data exploration, analysis, visualization, and machine learning. So you can think of this Cloud Data Lab as a tool that is used for visualization of different data or matrices. It will be having different kind of graphs or in the form of a table or matrices. You can see different kind of data in the data lab, and it runs on a cloud engine and may connect to multiple cloud services. So a dedicated compute engine is assigned to this data lab, which will be having its own VM, and it may connect to multiple cloud services, maybe database services or machine learning services. You want to integrate it, you can directly integrate, and the matrix will be directly visible on this data lab platform. Now, it's an open source project that is built on Jupyter Notebook platform. So Jupyter Notebook is an open source project, and Google Cloud leverages this platform to make their own application, that is Data Lab. Now it enables analysis of data on the BigQuery, Cloud ML Engine, Cloud Storage, and many of the other GCP services. You can directly integrate with it, and whatever you integrate, you will be able to visualize the data related to that service. All right, and now it supports Python, SQL, JavaScript languages. So I think it's pretty easy to understand what is the data lab, and that's all about the data lab that we'll discuss in this lecture. So now let's have a look at Google Cloud BigQuery. So it's a serverless scalable cloud data warehouse. Serverless doesn't mean it does not have server. It's like you don't have to worry about its infrastructure and scalability. It's all taken care by GCP. Like setting up the infrastructure, provisioning, scalability, all those things will be taken care by GCP. Now it has an in-memory business intelligence engine and machine learning. So the task that you are performing with the BigQuery, it has capability of machine learning and perform some business intelligence operations that can be used for understanding what's happening with the data that you are feeding. Now it supports NC SQL dialect for querying. You don't have to learn any new languages for using this BigQuery. Only the languages that you already know for querying the SQL database, like select statements with some join clauses like inner joins, outer joins, or group by, can be used for querying the datasets. It supports federated queries that can process external data sources. So it means that it can pull the data from cloud storage, cloud big table, or any other spreadsheets that's there in the Google Drive. So you don't have to worry about where the data is coming from. You can pull whatever the resources you have in GCP. You can pull the data from those resources using some simple SQL queries with the join statements and group by statements. All right, automatically replicates the data to keep 7 days of changes. So it maintains a 7 day history. So you can go back in time and you can see what all the operations you have performed in the last 7 days on any data. You can see it, you can replicate it, you can make changes to it. That's one of the key advantages. Now it supports data integration tools like Informatica and Talend. So these tools are very widely used for machine learning and performing business intelligence operations. So you can very well integrate this BigQuery with these two tools. And if you look at the bigger picture, it has a very huge use case. So it's time for us to look at the demo using BigQuery. So here once again we are on to a demo section where we are going to see a demo on the BigQuery. We will use a public data to perform some actions using the BigQuery. So we are onto the Google console here, and in here you will type the BigQuery in the search bar and will find this BigQuery link. Now we are onto the BigQuery console where you can see the BigQuery and you will get a dashboard like this. So in here there is a workspace and you can write your queries in here. And in the section in here you can see the personal history, the project history, and the saved queries. You can see it here, right? So now what we are going to do in this demo is we are going to perform a query on a public dataset, that is Stack Overflow. If you are aware about the Stack Overflow, you might be aware that it's a forum for IT engineers where you ask a question and somebody replies for your question, right? So the users who ask the question and the users who answer for your questions, they get a badge. Badge is based on the number of good answers or the good questions that you have asked. The people will upvote you. You will get the badges according to that, right? If you want to deal with huge amount of data, you can use this BigQuery for running any kind of query that takes longer than usual. Okay, so you can very well go ahead and add your projects in here, or you can perform any kind of query on the public data that is available to public, and you can also add some external data sources for running your queries. So in this case we don't have any project that is having a huge amount of data, so we will go with the public data set. When you click on this public data set, it will open up the public data sets that are available for free for your practice purpose or for your research purpose, right? So in here we are going to perform some operations on Stack Overflow. Stack Overflow has given its data for the public use, and you can very well go ahead and use this Stack Overflow data view dataset. This will open up a new window, and in that window you will be able to run your query. So I have got this BigQuery public data, right? And this data is basically coming from your Stack Overflow. Okay. For testing purpose, we have written a query that will run on the dataset that we just imported, the Stack Overflow dataset, and that will basically find out the users who have got the gold badges and how many days it took for them to get that badges. And we have also limited the number of limit to 10. That means that the top 10 gold badges user will be displayed and how many days it has taken for getting those badges, right? Let me copy the query and go to my BigQuery screen, and in here I will go to the editor and I will type my query in here. I will give the link to this query in the description. You can find it in the description, or you can also find it on my website given in the description. So I have written the query. Now I am going to run this query. If you see here, this query will process 1.7 gigabytes when it runs, right? 1.7 GB is not a joke. It's a very huge amount of data that our query is going to run, and we will get the results. And we have got the results within zero point 0.0 seconds. That's because it's cached. So this is one of the advantage. I have run this query before and it took me 3.2 seconds for getting the data for the first time. If we consider this 3.2 seconds of time for running over 1.7 GB of data, that is unbelievable. And also if we are performing the same query once again, it is cached. So this is the best advantage of BigQuery, right? Now let's see what we have got in the result. So these are the badges, the name of the badges. First gold badge, and the famous question badge, the number of users are 3,81,000 something, and it took 1565 days for getting this badge, right, to this many users. Now similarly there are other badges, copy editor, great question. So all this data we are getting it from Stack Overflow, and that too within milliseconds, and that's a very big advantage of using this big data. All right. Now, after the demo, it's time for us to look at the use cases of Google Cloud Analytics services. Now, the first one is the Google Cloud Pub Sub, which performs very high speed ingestion of data. And wherever you have a sensor data or telemetry data or the logs that are coming in, you can use this Pub Sub for ingesting the data to the GCP. Okay. Now, the cloud data flow, it can be used for stream and batch processing. So the data that you get from the PubSub, that can be used for ingesting into the cloud data flow, where it can be used for performing business intelligence and machine learning operations. So this ETL here stands for extract, transform, and load. The next is the data proc, which is basically used for the map reduce jobs, and it is widely used with Apache Hadoop and Spark. So use case can be the map reduce jobs. Now the data lab, basically that is used for visualization, and it is basically based on Jupyter Notebook for interactive analysis. So it's very well integrated and it provides better visualization to the data that you are ingesting. Now the BigQuery that we just saw in the demo, that can be used for business intelligence or machine learning also. So you can perform any kind of SQL queries on the data and get the required data out of it. So these are the use cases of all these services, and I hope that you have understood most of it, how to use it, where to use it. So that completes the section on Google Cloud Analytics platform. Hello everyone and welcome once again to the new section. And in this section we are going to start with AI and ML services, that is artificial intelligence and machine learning services that are provided by Google Cloud platform. So let's have a look at the learning objective of this video. We are going to start with the overview of machine learning and artificial intelligence services. Then we'll move to cloud AI building blocks that provides us the APIs for machine learning, and the cloud auto ML that is used as a training platform for machine learning APIs. Then we'll move to AI platform, AI hub, and we'll have a demo around image recognition with Cloud Vision API. And finally, we'll move to the use case of AI and ML services. So let's get started with the overview of machine learning and artificial intelligence. So the AI building blocks provides AI through simple REST calls, which means you don't have to be a data scientist or machine learning engineer for using the AI in ML services of GCP. You just have to call the REST API and it does all the intelligent work for you. Now the Cloud Auto ML enables training modules on custom datasets. It means that Auto ML platforms are used for training the APIs on the custom datasets that can be very huge in size or even medium size. It can be used for training the APIs. Now the AI platform provides end-to-end ML pipeline for on-premise as well as cloud services. It takes care of training, tutoring the models, and even deploying the models on the AI platform. Now the AI Hub is a Google hosted repository to discover, share, deploy ML models. So you can think of it as a repository of services or resources that can be shared within teams, or it can even be made public. Now the Google Cloud Platform offers comprehensive set of AI and ML services for beginners and advanced AI engineers. So more about all of this further in the video. So now let's look at the cloud AI building blocks. So as I mentioned earlier, you don't have to be a data scientist or machine learning engineer to utilize the AI applications of Google. So for example, if you see here, we have subdivisions of applications inside GCP. So first is the site, that is basically the things that you visualize. There is a vision API that derives insights from the image in the color. So it exposes a API where you provide your image and the API gives you all the objects that are available in that image. So that's a very good example of vision API and we'll also see that in the demo section. Now the video enables powerful content discovery and engaging video experience. The next is the conversation related applications, that is Dialogflow. Basically, it is having a virtual agents that will give you the experience of conversation with a robot, and you will not realize that you are talking to a robot. Okay. There is a text to speech API that converts your text to a speech. So you just provide your script to a API, and that will give you a human like speech audio file. Okay, that you can use for any podcast or in your YouTube as well. Okay, the next is speech to text. If you are speaking something, it will write to a text file automatically and with a greater accuracy. The next is the language, where you can see that this is already there in place, that automatically detects your language, whatever the language you speak, and it translates it for the other person. There is a natural language processor where it is used for deriving the meaning of the word that you are speaking. Basically, it is used in the Alexa, where you say a command and it will recognize the command and it will perform actions on it, right? And there is also some applications which are used for structured data like auto ML tables. So automatically builds and deploys state of the art machine learning model on structured data. There is a recommendation API which gives you a personalized experience for the product recommendations. And there is a cloud interference API that runs large scale correlation over time series dataset. Okay. So these are all the building blocks of GCP that provides us the API, and we have to use that API to get the task done. You don't have to know what's happening in the background. You have to use that APIs to get your tasks done in an easier way and a smart way. All right. Now, after learning about the cloud building blocks, let's have a look at Cloud Auto ML. So, Cloud Auto ML enables training high quality models specific to your business problems. So, in the building blocks, we saw that we are using the APIs for getting our task done, but we don't know what's happening in the back end, right? We can assume it as a black box where we don't know what's happening. We just using the APIs and we are getting the task done, right? But in AutoML, it's one step ahead, where you can use this AutoML for training your APIs for getting the task done specific to your business, right? And you don't have to write much code for getting the things done, okay? And AutoML is based on state of the art machine learning algorithm. So you can apply the AutoML on services like vision or video intelligence, or you can also use it on language, natural language and translation, and you can use on the structured data. All right. So let's assume a business problem where you are using the vision API for identifying what's there in the picture. Let's say that in the picture there is a dog. So if you provide this picture to the vision API, it will give you like this is a dog and this is an animal, right? And what if your business requirement is if you want to identify the breed of the dog, right? So this is where the AutoML comes into picture, where according to your business requirement, where you feed the certain data set in a structured manner, where you identify the dogs based on some specific breed and you feed it in the tabular data. So this algorithm trains itself like whenever there is a dog which is having some properties, identify the dog that it belongs to a particular breed. All right. So you don't have to write so much of code. You just have to provide the data and it will be doing the hard work for you. So that's the use of AutoML. In a single line, you can say that it's used for training the APIs for performing more specific tasks. Now let's move one more step ahead and learn about Google Cloud AI platform. So the building blocks and the AutoML provide certain kind of capabilities like using the APIs and training the APIs. The Cloud AI platform is one more step ahead of the Cloud ML. So Cloud AI platform adds some of the more capabilities. So if you're not a data scientist or you don't know machine learning, then you can go for building blocks and auto ML by using the APIs and training platforms. But Cloud AI platform is basically meant for the data scientists and engineers who want to develop the platform to push the boundaries and add some more capabilities to the platform based on their need. Okay, so basically it covers the entire spectrum of machine learning pipeline. Okay, and it's based on Kubeflow, that is an open source machine learning project, and it's based on Kubernetes. Okay, and it includes tool for the data preparation, training and inference. So if we go into the details of AI platform, there are so many stages where you need to perform certain kind of action, right? And each of the action takes more time. Let's take this diagram here. So if you see here, there are so many things that has to be done in order to deploy an application. And if you consider each of these tasks, it takes a certain amount of resource and time for doing the work, right? Like discover, develop, and test and analyze, deploy, right? So the Google AI platform provides and manages the tool that can go through all these pipeline stages, and you can easily scale it up and scale it down based on your requirement. So basically using the AI platform, you develop something where the end product can be a auto ML or an API that we saw earlier. Okay, so that's the use of AI platform. Alright, so let's have a look at the Google Cloud AI Hub. So Google Cloud AI Hub is one of the recent additions in the AI portfolio. It's a hosted repository of plug and play AI components. So you already know what is repository. It's a workspace where you keep most of your components, right? So during the development of AI models and ML models, there are lots of artifacts that are generated from datasets to fully trained models to Jupyter Notebook and the artifacts that can be used for deployment and so on. The AI Hub acts as a single source of truth, that it is the database to all those artifacts and entities generated during the development of machine learning module. Okay, and it makes it easy for the data scientist and the teams to collaborate. So you have developed a component, you can place it in the repository and you can collaborate with other team members. It contains the private as well as public content. So the private content can be shared within the team members and the public content has the public access. Whoever is going to use the AI hub, they will be having the access to this publicly hosted components. Okay, so AI Hub includes some of the components, that is Kubeflow pipeline component that was discussed in the previous slide. There is Jupyter notebooks, then there is a TensorFlow modules and the VM images, fully dedicated images are available for AI Hub and the train models. Alright, so this is all about the AI Hub. I will be making a separate video on AI Hub in which we will cover everything related to all these components, but that will not be a part of this series. It will be an independent series. All right. So that's all you need to know about the AI Hub in this section. It's time for one more demo. And in this demo, we will look at image recognition with the Cloud Vision API. So with the use of Vision API, we will give image as an input. It will recognize the image, what all things are available in that image. It will give it as output. So for using the Vision API, we will not be using it programmatically. We will use just an interface of Vision API by going to cloud.google.com/vision, and this will take us to the demo page of Vision API, where we can use the web console for checking out its capability. Now you can also use it programmatically by using this documentation. You can integrate it with your applications. But in this demo, we are going to use the web console itself. So let's import one image in here. So this is the image I'm importing it. And the Vision API basically tracks down the image and it searches for everything that is available in that image. And you will get the results in here. So you can see that the objects that are there in this image, that are watermelon, pineapple, fruits, banana, and other fruits, apple, and here is a percentage that is matching. So if you hover on each of the items here, it will be highlighted. You can see this highlighted box, and it is able to recognize what all the things are there in this API. If you go and see in the labels also, these are the labels or the tags, you can say, that are used in this image, right? We can check out the properties, which tracks down how much of which color is used, which is the dominant color. And in the safe search, you can see filter out what's the content about. If it's a violent content, very unlikely. If it's a adult content, it's a very unlikely, right? Along with that, you get option for JSON objects as well. So this is the API that is exposed, and this is the request that we have sent in the JSON format that's happening in the backend. And the response that we are getting, that is basically the boxed format, the verticals where that item is available, all this is coming in a JSON format. So it's a very clever API that you can use to integrate in your application wherever you have need for identifying objects or things, right? This is one of the capability of Vision API. Likewise, there are n number of AI tools that are used for different purposes, like optical image recognition. Take an image and it will extract out all the text from that image. There are audio to text applications, or also there are text to audio applications where you don't need to speak anything, you just write the text, everything will be converted into a natural language. So these are all the capabilities of AI and ML, right? Let's move to the last section, that is the use cases. The first product that we discussed was the cloud building block that basically exposes a REST endpoint, and we can use that in our apps with just one API call to take the advantage of that API. So it's a simple API for vision, language, and data. Now, the Cloud Auto ML provides model based on custom datasets, and it has no code approach to train high quality models. Okay, so its use case is basically to train and deploy models and custom datasets. The AI platform is basically a pipeline, that is a machine learning pipeline, and it's used to train models on-prem and deploy it on the cloud, or vice versa. It's an open and portable framework for machine learning. The AI hub basically is a artifact repository where data scientists and teams can share their directory of various ML components, reuse the existing components that are shared by other users. All right, so that's all about AI and ML in this lecture. Hello everyone, and welcome to the new section where we will discuss about Google Cloud DevOps services. So let's have a look at the learning objective of this video. As obvious, we are going to start with the overview of developer tools and DevOps services, cloud source repositories. After that, we'll move to cloud build. then container registry, IDE integration, and after that we'll have a demo for storing a Docker image into container registry. And finally, we'll wrap up the section with the discussion around use case of developer tools and DevOps services. So let's get started. So before moving further, if you are not subscribed to the channel, I request you to please subscribe. So the overview of GCP DevOps services. So DevOps services provide tool and framework for automation. So if you are a developer or a DevOps engineer and you are looking for automation and getting the things quickly done, then you should go for GCP DevOps services. All right. So what all things it has to offer to the developers and the DevOps engineers, we'll see in this section. So the cloud source repository store and track source code. So this cloud source repository basically it's like a GitHub or GitLab. This is the one that Google provides for storing your source code and tracking it. If you already know GitHub and GitLab, you will be able to understand these cloud source repositories. Now the cloud build automates continuous integration and deployment. So it's the CI/CD pipeline that is provided by GCP basically to do the continuous integration and deployment. It can also be integrated with third-party tools like GitHub or GitLab for taking the build from there and starts its deployment. It's similar to Jenkins. So the container registry acts as the central repository for storing, securing, and managing Docker container images. So if you have a microservice and you have a container images, then it acts as a repository where you can store all your Docker images and other artifacts and manage these containers for deploying from this location. All right. And IDE and the tool integration enables developer productivity. So it also provides us the IDE and the tool integration so that the developers can integrate their application with the IDE for better management and deployment using this IDE. So that's the overview of DevOps tools. And now let's look at them one by one. So the next one is cloud source repositories. So it acts as a scalable private Git repository where you can store your code and all the developers and DevOps team can make use of it. So it extends standard Git workflow to cloud build, cloud PubSub, compute services. So the idea here is that your source code, when you are using the cloud source repository, will be close to the GCP environment. All right. So it will use the same network services that other GCP applications are using, and your source code is in the same environment. So if you want to deploy your code, it will be using the same network. So build, deploy, and perform all the CI/CD pipeline activities. So it will be having low latency and the processing will be very faster because everything is in single network, right? Now unlimited private Git repositories that can mirror code from GitHub and Bitbucket. So it provides you unlimited private code, that is you can secure your code, it will not be public and it's unlimited, and you can also mirror your code from the GitHub and Bitbucket. So you can replicate the GitHub code and Bitbucket code in your cloud source repository, right? It triggers automatically build, test, and deploy your code. So there is a trigger whenever you push your code to cloud source repositories, it triggers build, test, and deploy. Now you can enable this trigger or disable it based on your requirement. All right. It's integrated regular expression based code search. So if you have a large database of code, you can use that regular expression for searching a particular file or a particular line of code. All right. It's a single source of code for deployment across GCE, GAE, GKE, and Google Cloud Functions. So if you are using this cloud source repository, you can deploy your code anywhere in the GCP cloud. It may be Compute Engine or App Engine or Kubernetes Engine or Google Functions. All right. So let's now have a look at the Google Cloud Build. So it's a managed service for source code build management. Means that once you complete your code, you need to deploy it somewhere, right? So in order to deploy it, you need to build your code, right? So Cloud Build is a CI/CD tool, that is continuous integration and continuous deployment tool, that will manage all your build process. You don't have to do certain operations in order to deploy your code. Let's have a look at the example in here. Let's assume that these boxes are the steps that are involved in deploying your code. Alright, so let's say that the first one is for pulling your code from Bitbucket or Google Cloud Source Repository or anywhere where your source code is located. Alright, and the next step in the deployment is the quality check, where it runs certain kind of checks to find any issues with your code. The next step can be the test, basically running your unit test cases. The next step can be dockerizing your code, building the image for your code, and finally it will be deploying your code. All right, so the cloud build says that don't do all these steps manually. Instead, you make a pipeline where I will perform all these codes for whatever environment you provide and for whatever code you provide. All right, so let's say that you want to deploy your code in the QA environment. So you provide the URL of your source repository along with the branch information, and you trigger with a button. It will just take the latest code from that branch and it will start quality check and perform all these steps, and it will be finally deploying it. So you have to write a one-time script for quality check, for testing, for dockerizing, and all those things will be taken care from the next time. So if you have a very frequent release cycle, let's say 1 week or 2 weeks, so you don't have to perform all these steps. It will save a lots of effort for the developers as well as the DevOps team. All right. So it supports building software written in any language. It doesn't matter whether your code is Java or Python or any other language. You have to just provide the source code location and it will deploy by following all these steps. It's a custom workflow to deploy across multiple target environments. Now you wanted to deploy that code for a QA environment. Similarly, you can deploy your code in the dev environment or in the prod environment. And similarly, you can deploy your code in any target environment, let it be GCE or GKE or even on the cloud functions. All right. It's tightly integrated with the cloud source repo, GitHub, and Bitbucket. So you can give the URL of even a cloud source repo, Bitbucket, and GitHub. It will start taking your code from there and doing the build. It supports native Docker integration with automated deployment to Kubernetes and GKE. So it supports Dockerization, where you give your code, it will build the Docker image, it will take the backup of that Docker image into some kind of repository, and you can perform the Docker tags and Docker build as well using this cloud build. Identifies vulnerabilities through efficient OS package scanning. So as I mentioned, there is quality check in here. It will be checking for all the issues that comes in. It will be performing certain kind of task, and if it finds any kind of issues, it will not let the code move forward to the next step. It will fail here itself. You have to go back and check the logs in order to identify what failed. All right. So this is all about Google Cloud Build. Now let's have a look at container registry. It's a single location to manage container images and repositories. So you already know what is a repository, where you store all your artifacts or jars or anything that is important for your project, right? So container registry basically stores the container images, all right, or the Docker images in one place. Why it stores it? As in the previous slide we saw, there was a step where the Docker was involved. When your code is coming through the pipeline, it comes to Docker, it forms a Docker image and it stores it in a container registry. The next step will take the image from that registry and start performing the build on that image. All right. So it stores all the images that you are making using the pipeline. It stores images close to the GCE, GKE, and Kubernetes cluster. So whether your application is running on GCE or GKE, it will be storing in the same network where your code is being deployed. all right, so that it will increase the performance of your application and it will not be having any lags. It's a secure, private, scalable Docker registry within GCP. So the person who is having only access to this container registry can access. So it's a secure and private. And you can store any number of images. It can be scaled up in the memory as well. Now it supports RBAC, that is role-based access control, to view, access and download the images. So it's very much secure. It uses the IAM policy for role-based access control. Detects vulnerabilities in early stage of the software deployment. So once your image comes in here, there is a background check that is performed on this particular image, and if it is vulnerable, it will be marked as red and it will not be provided in the next step, or it cannot be moved to the production. It will be locked out. So supports automatic lockdown of the vulnerable container images. So if it finds any vulnerability, it will be locked down. Automated container build process based on code or tag changes. So whenever there is a change in the code, it will be building the image, or whenever you change the tag of a particular image, it will automatically detect it and start the build process. All right, so that's all about container registry. So now it's time for us to learn about developer tools. So developer tool is a IDE plugin for popular development tools like IntelliJ, Visual Studio, Eclipse, and so on. So you can use the developer tools in these plugins for making your task more simpler. Developer tool has a tight integration between the IDE and the managed source code management systems and the build services. So when you install this plugin in your Eclipse, you will be able to push your code or pull the code or even trigger the build from your IDE itself. Automates generating configuration files and deployment scripts. In order to deploy and build your file, you will need the configuration files and the deployment scripts, Docker scripts and similar other scripts are there. So it will automate all those manual activity when you use this developer tools. It makes GCP libraries and SDK available within IDE. So whenever you want to integrate any Google services, you will need the libraries, right? And the SDKs. So this plugin basically it will pull the libraries that are required for integrating that particular tool or application. It enhances the developer productivity, so you don't have to run here and there for getting the libraries or for making the deployment script or download the git patch for pulling and pushing your code. All these things are taken care by this developer tool, so that enhances the productivity of developer. All right, let's have a demo on container registry. So in this demo we will be storing a Docker image in the container registry. So what we'll do, we'll get an image, a Docker image basically. Then we will make some changes in that image, and after that we will push that image on the container registry. So let's go to our Google Cloud Console. So we are on our Google Cloud Console and let's search for container registry. So it's here, container registry, and if you see here, you can see the images tag here, and there are no images currently, that's why this is empty. Now we are going to run some set of commands on the Cloud Shell so that we can get the image, make some changes in the image, and then we can push that image on the container registry console. Okay, so let me open up the Cloud Shell. So the Cloud Shell is started. Let's have a look at the commands that we are going to run in the Cloud Shell. First of all, we'll run this command: gcloud service enable registry Google registry googleapis.com. This will enable the container registry of the Google APIs. Okay, after that we will declare a variable, basically the project ID, and in this project ID we will replace this with our project. In my case the project ID is technotab. Don't forget to replace it. Then we will do a docker pull busybox. Actually busybox is a very small container image that is having all the utilities of the Unix. We don't have to bother about what's inside this busy box. We just have to know that it's a container image that we have to pull, and then this command docker images command is used to display the images. After that we will create a file, the docker file, and in that docker file we will have only this text, that is latest cmd date, that will display the date. So if we don't have the docker file, our docker image will not be built. Okay, and this command is used for building it. The docker tag command is used for tagging that image, basically with the name that you extend here. Docker run is used for running that image. After that we will authorize that configure docker, so that it takes our Google credentials for configuring the docker, and after that we will push the image. So these are all the steps that we are going to perform. Let's start with the first command. Go to the cloud shell, just type the command, and this will enable your container registry. So it has enabled. Now next is the export project ID. This project ID, let me give my project ID here. If you don't know where you get the project ID, you can just click on this project, and you can say this name of the project, and you see the ID, right? So you have to give this ID, enter. This is just, we have created a variable project ID that is storing our project ID. Let's go to the next command, that is docker pull busybox. So basically this will pull the busybox image. Okay, and you can see the image by using the command docker images, and these are the list of images that will be shown. You will be getting only one image, that is this busybox image. I had some other images already there, that's why it is listed here. We can see that this busybox image is listed here. Let me go ahead and create this file, docker file. Click enter, and this file will be created, and this docker file will be having busybox latest and the cmd date. You can also go inside this docker file and check what is the content of it by giving the command vim docker file. Okay, so here I have run the command for 2 times. Before also I had run this, so that's why it is coming for 2 times. Let me delete it, the previous one. And for saving the file, just click on colon wq exclamation enter. Now it's time for us to build the image. So this command is for building the image. Basically I'm building with the name my busybox. The build is successful. Now we are going to tag this image with different name, that is docker tag. With this particular name we are going to tag it. Tagging is done. Now we are going to run this image, and if we run this it will print the date and time, because in the docker file we have that date and time. Okay, now we will use this command auth configure docker. This will be internally already done. To confirm that if you are not already configured, you can run this command. Here you can see that G Cloud Credential Helper already registered correctly, right? And after that we will give the final command, that is docker push and the latest image that we have created. So the image is pushed, and
if you come down here and refresh this page or click on the image, you will be able to see image in here, and this image you can pull it from anywhere from your pods. You can go and run this image, or you can export this image to anywhere you want, right? So that was a very comprehensive demo, and in this demo we learned that how we can register any image in the container registry. All right, so let's move to the next section, that is use cases of Google Cloud DevOps services. So the Google Cloud source repository, so that is basically a private source code repository where you store your code securely in the cloud, and the service type is SCM, that is source code management, just like Git Bash and Bitbucket. The next is Google Cloud Build, that is basically used for build and deploying your code. It's similar to Jenkins, where you provide your source code and it will perform all the deployment activity. So it's a pipeline to deploy code automatically from source code. Okay, and we call it as a CI/CD, continuous integration and continuous deployment. The Google Cloud Registry Service basically acts as a repository which stores private image close to your compute services. So it will be using the same network where your code is being deployed, and it will be very fast. Stores the image in the same region as GKE cluster, and it's a private container registry. Now the IDE integration, basically it's a developer tool. This is the plugin that you have to use in order to increase the developer productivity by manage and deploy apps just from the IDE, that is IntelliJ or Eclipse or Visual Studio. So that completes the section on DevOps services. So if you learned something from this video today, I request you to please like it and provide your valuable feedback in the comment. And if you are not subscribed to the channel, I request you to please subscribe it. It's totally free of cost. You are not going to lose something, but it will give me the motivation to make more such videos like this. So with that, I complete this section here, and thanks for watching. See you in the next video.